Hello everyone. Today we're going to talk about chapter 6. Chapter 6 is about discrete probability distribution. We're going to discover these topics. We're going to talk about how we identify the characteristic of a probability distribution, how we can know the differences between discrete and continuous random variable. Also, we're going to talk a little bit about the mean, variance, and the standard deviation of a discrete probability distribution. Also, we're going to talk about the binomial distribution and how we can calculate that. Lastly, we're going to talk about the hypergeometric distribution and how we can calculate that. So first, what is a probability distribution? It's a listing of all outcomes of an experiment and the probability associated with each outcome. So let's say I have an experiment and I have multi outcomes. Let's say I have 3 outcomes from this experiment. Okay, so it's listing for all of these outcomes, okay, associated with the probability for each outcome. So let's say for this one, the outcome is 2 over 10, for example. Third outcome is 5 over 10. Last outcome is 3 over 10. Okay, so these are the list of all outcomes, and this is the probability associated with each outcome. And remember, the sum of all outcomes, it should be equal to 1. This is important. Sum of all outcomes should be equal to 1. Now, what is the characteristic of a probability distribution? It's the probability of a particular outcome is between 0 and 1 inclusive. The outcome are mutually exclusive. This is important. Mutually exclusive. The listing of all outcome is exhaustive. So the sum of the probability of the outcomes is equal to 1. As I said before, the sum of all outcome, the probability of all outcomes, it should be equal to 1. Okay. So for example, a drug manufacturer may claim a treatment will cause weight loss for 80% of the population. Okay, so a consumer protection agency may test the treatment in a sample of 6 people. They won't do the experiment on the whole population due to the protection. So they want to only choose a sample for 6 people to do the experiment. So if the manufacturer claim is true, okay, so it's true that the drug will cause weight loss, it's almost impossible to have an outcome when no one in the sample lose weight, and it's most likely that 5 out of the 6 do lose weight. Okay, so to say this experiment is correct, at least I should have 5 people out of the 6 they are losing weight, and then I could say the claim is true. Okay, I chose a sample from the population to do the experiment. If I got 80% of this sample weight loss, they lose weight, sorry, then I could say the claim is true. Okay, so we have formulas for the probability distribution. We have a mean, variance, and standard deviation. Okay, also binomial and hypergeometric distribution. This the type of the distribution in this chapter. We're going to talk about each of them a little bit. Okay, so to sum up, before we start the chapter, we will begin the study of the probability distribution. Okay, don't mix up the probability distribution, and then they will give us the entire range of value that can occur based on an experiment. Okay, so the reason why we have to look to the probability distribution, because it will give us the entire range of values. Okay, now the probability distribution is similar to the relative frequency distribution. We took this in the previous chapters, but instead of describing past, it describes likely future event. Okay, so the big difference is here. The probability distribution is describe the likely future event. Okay, here we're going to talk about the future. In relative frequency distribution, when we look at it, we always describe the past, okay? But now we describe a future event. So we will discuss the mean, variance, and standard deviation. We also will discuss the three frequencies occur in probability distribution. We're going to talk about binomial and hypergeometric. Okay, so let's say in this example. So I have this example. Suppose we are interested in the number of heads shown face up with 3 tosses of coin. So I have 3 coins. Okay, I have 3 coins, and I only interest. Okay, remember each coin, it has 2 possible outcomes, either head, the picture here, either head or tail. Okay, so if I have a coin, if I flip it, either I will have head or tail. Okay, same for the other coin, either I will have head or tail. Same for the last one, either I will have head or tail. Okay, so in my experiment, I'm only interested on showing head. Okay, this is my interest. Now, the possible outcome, it's gonna be 0 head, which is, that's mean all the coins will showing tail. If all the coins showing tails, that's mean I have 0 head. Okay. Now, if I have one coin showing head and the other coins showing tail, then I'm gonna say the outcome is 1 head. Okay. Now, if I have 2 of the coins showing head and 1 showing tail, then I'm gonna say the possible outcome is 2 heads. Now, if I have all my coins showing head, then I'm gonna say I have 3 heads. So this is my possible outcome. Okay, so if I did the experiment and then no one of these coins, okay, no coins showing the head, only tail, so I'm gonna say this is 0 head. Okay, if I did it again and I have the first one, yes. So if I did it again and then I have first one head, second one tail, and this is tail, so this is the second option. So I have one possible outcome. Now, if I repeat it and then I have the first one tail, second one head, and third one tail, then it's gonna be 1 head also. So how many times that I got 1 head, sorry, is 2 times when I did the experiment. Now, if I repeat the experiment, okay, and then I get the third one, it's head, then I get this outcome for 3 times. So when I did the experiment 3 times, I will get 1 head, okay, because I have 3 coins. Sometimes the first coin will be the head, sometimes it's the second coin, some or other times gonna be the third coin. That's why it's repeated 3 times. So the possibility that I will have 1 head in my experiment is 3 times. Okay, so it's 3 times. Now, if you do it the same for 2 head and 3 head, it's gonna be the same idea. Now let's say what is the probability distribution for the number of head? Okay, so this is the possible outcome. Okay, this is the possible outcome or the possible result. So I have 1. This is the number of the experiment. It's gonna start the first time I did the experiment, second time, third time, fourth time, and so on. Okay, so this is me, the number of time that I did the experiment. Now, the first time, okay, this is the first coins, second coins, and third coins. When I did the experiment the first time, I got 0 hit. Okay, so that because I got one coin as a tail, second coin as a tail, and the third coin as a tail, so I got 0 hit. When I did the experiment in the second time, I get the first coin tail, second coin tail, and third coin as a head. So this is in category 1. Remember, we said 0 if I have no hit. Okay, 1 if I have 1 hit. 2 if I have 2 hits. 3 if I have 3 hits. Okay, so now the number of hit is 1. I did the experiment in the third time. So the first one I got tail, second coin I got head, and the third one I got tail. So now I'm still in 1 because I only got 1 hit. Now in the fourth time I got 2 hits. So this is 2. In the fourth time I get only 1 hit, so still 1. So this is all the possible outcome. Okay, now for the possible outcome, I can find the mean and the variance. But first, let's say how we can describe this. Now, one second. Okay, so describe the probability distribution table and the chart for the event of 0, which is no hit, 1, which is 1 hit, 2, 2 hits, and 3 hits. Okay, so this is the table. So now, how many times the 0 it's appear? It's only 1 time. How many possible results is 8? So I'm gonna divide it by 2. Remember, the probability of x is the probability of x divided on the total. Remember this. So now the probability of 0 is only 1 time and is divided by 8, which is the total of possible results. The probability of if I have only 1 hit is 3 times because I did the experiment and 3 times it's repeated that I have only 1 hit. So it's 3 over 8, which is equal to 0.375. Now, the probability that I have 2 hits, it's also 3, because from the table, I get 3 times 2 hits, so it's 3 over 8. The probability I have 3 hits is only 1 time, so it's 1 over 8. Now, if you calculate the total, it's going to be equal to 1. Okay, this is important. Now, let's talk about the random variables. In any experiment of a chance, the outcome occur randomly, and so are called random variable. Okay, in any chance of any experiment of a chance, the outcome occur randomly, and so are called random variable. Some experiments result in outcome that are quantitative, such as dollar, weight, number of children. Others result in qualitative outcomes, such as color, region, and preferences. Each value of the random variable associated with the probability indicate the chance of a particular outcome. Okay, so random variable is a quantity resulting from an experiment that by chance can assume different value. Okay, for example, the number of employees absent in Monday, the number might be 0, 1, 2, 3. The number of absent is a random variable. Okay, so because it doesn't have an exact value. The grade level, freshman, sophomore, junior, or senior of the member of basketball team, the grade level is randomly variable. Because if I choose person, I don't know if it's whether freshman or senior, so it could be one of them. Okay, now the following diagram illustrates the terms experiment, outcome, event, and random variable. First, for the experiment where a coin is tossed 3 times, there are 8 possible outcomes as we described before. Now, in this experiment, we are interested in the event that 1 hit occur in the 3 tosses. So now, I'm interested only in 1 hit occur. Okay, so the random variable is the number of hit. This is the random variable. Is the number of hit Okay, so we want to know the probability of the event that the random variable equal to 1. Okay, so when I did the experiment, I find out this is only my outcome for only one hit. Okay, so this is how many times one hit is repeated, is only 3 times. Okay, so this is 3 events. Okay, um, a random variable may be either discrete or continuous. Okay, so this is, you have to understand the random variable, it's going to be either discrete or continuous. And what is the difference between them? We're going to study that. This is the differences between the type of distribution. Now, usually a discrete distribution is the result of counting something. So here you can count in discrete. Okay, in continuous variable, it's a result of measurement. So this is a big difference. Now, for example, in counting, if you count the number of hits appearing when coin is tossed 3 times, you can count how many numbers of hits. The number of students earning A in this class, I can count how many numbers of students. Okay, the number of production employee absent from the second shift today, I can count them. It's either 3, 4, 5, 3 or 4 employee, they are absent, so I can count them. There's no measurement involved here. The number of 3-second commercial on NBC from 8 to 11 tonight. Okay, so the number, I can count that. Here in measurement, the weight of each student, I cannot know the weight without measurement. I have to measure the weight. So that's why we say type of measurement. Now the temperature outside, you cannot say the temperature today without measure. Okay, so you have to measure here. The amount of money earned by each of the more than 750 players currently in the Major Baseball. Now, the amount of money, you have to measure that. Okay, you have to go ask, calculate. So this is measurement. Okay, now in counting is different. You can count them by your hand, it's easy, but in measurement you have to apply advanced level by using some type of measurement. So this is the big difference here. Now, two types of random variable. One type of random is called the discrete random variable, are usually the result of counting. Okay, as we said before, it can assume only clearly separate value. Can assume only certain clearly separate value. Example, tossed a coin 3 times and counting the number of hits. A bank counting the number of credit cards carried by a group of customers. Now, in this, for example, this is the Bank of Caroline count the number of a credit card carried by a group of customers. Okay, so the number of card carry is a discrete random variable because I can count them. Okay, so how many customer that? What is the probability that customer doesn't have any card? It's 0.03. One card is 0.10. Two cards, the probability is, or the relative frequency is 0.18. So I can count them. This is an example. Now, in continuous random variable, it can assume an infinite number of value within a given range. Okay, so continuous variable are usually the result of measure. It's measured in the continuous interval or ratio scale. This is important. So it's measured in continuous interval or ratio scale. As I said, continuous involve a high advanced type of measurement, so you can look only to the interval or scale. Example, the time between departure flight from Kaya are 0.23 minutes, 0.3 minutes, or 15.8 minutes, and so on. So you can measure the time here by minutes. The pressure measure as a FCI for the car might be 23 or 31. So you have to measure that to know exactly what is the pressure in your tire. So let's talk about the mean and variance of discrete probability distribution. Okay, so the mean and variance is important. It has some formulas. Okay, now the mean is typically the value you use to represent the central location of the probability distribution. Okay, the mean is also referred as expected value. Okay, now the mean of probability is mu equal sigma x multiplying by the probability of x. So this is the formula for mu in discrete probability distribution. So mean is equal sigma x multiplying the probability of x. Okay, now variance of a probability distribution, variance is equal to sigma x minus mu square multiplying by the probability of x. Okay, so you have this formula as the variance, or you have a shortcut formula, which is sigma x square multiplying by its probability and then minus the mu square. So you can use either this formula or this formula. So we have two formulas here. Okay, now how we can do the variance? We have 3 steps to do it. So first, subtract the mean from each value of x and then square it. And then multiply each square differences by its probability and then sum the result product to arrive to the variance. Okay, so this is in the original formula how we can do it by doing this step. Okay, so let's see an example. So John rapidly sells new cars for Blessing Ford. John usually sells the most cars on Saturday. Okay, say he's selling the most on Saturday. He has developed a probability distribution for the number of cars he expects to sell on Saturday. He expects, as we say, if the question asks you about expected value, then use the formula, the mean formula. Okay. So first, what is the type of distribution is this? Okay, is discrete or continuous? Here, in this example, there is no measurement involved and I can count how many cars he sells. So the type of distribution here is discrete, random variable. Okay, how many cars does John expect to sell in typical Saturday? Then we're gonna calculate the mean here. Calculate the mean. What is the formula for the mean? Is sigma x multiplying by the probability of x. Okay, so I have this table. This is the number of cars sold, and this is the probability. So I'm gonna take each one and multiply by its probability. So the probability of x multiplied by the bx, which is the probability. So it's gonna be, this is sigma, so it's gonna be 0 times 0.1. Okay, I'm gonna multiply 0 by 0.1 plus 1 times 0.2 plus 2 times 0.3 plus 3 times 0.3 plus 4 times 0.1. So I only multiply these by its probability. Okay, and then I'm gonna make a sum. So it's gonna be 2.1. Okay, so the mean here is gonna be 2.1. So the car does he expect to sell on typical Saturday is 2.1 because we calculated for the mean. Now, as we said, multiply x by the probability and then make a sum for the value. This is how you calculate the mean in discrete random in the probability distribution. Okay, now how we calculate the variance. So here 3, what is the variance? Then I have to apply the formula for the variance. So the steps, okay. Now, as I said, we have 2 formulas for the variance. So the first formula is sigma x minus mu square multiplied by the probability of x, or I have the shortcut formula, which is sigma x squared multiplied by the probability of x minus the mu square. Okay, so you have two formulas. You can choose which one you want to apply, but let's do now. For now, let's do both to see the differences. So first one, to apply this formula, create a table as we did here. Okay, so first step, subtract the mean from each value. We calculate the mean from the previous step, which is 2.1. Okay, so then I have to subtract the mean for each value of x. So x minus the mu, and then I'm gonna square it, square each value, and then last step I'm gonna take the square value and multiply by the probability, okay, to create the last column. Once I finish from the last column, then I make a sum for all of these value. So I got the variance is equal 1.290. Okay. Now, if I ask you to find the standard deviation, so then only take the square root of 1.290. Okay, so standard deviation taking the square root of the variance. Okay, now can I apply the second formula? Yes, you can. This is the second formula. So first you have to square each x and multiply by its probability. Then make a sum for all of these values. In the end, subtract it from square mu, square the mean. Okay, so first x squared times probability, which is 0.1, and then 1 squared times 0.2, and then 2 here, square, multiplying by its probability, which is 0.3, and so on. Okay, and then make a sum for all these values subtracted from the mean square, so the result is going to be 1.29. Okay, so using each formula, you should reach the same value. Okay, but just choose which one is easy to you to use. Now I have this question. The distribution of the number of traffic complaint a radio station program receive per day is listed in the below table. Okay, so I have a compliments in the radio station, and they wanted to know the mean for that. So the mean of the number of compliments received in the given day. So let's say how we can calculate the mean. First, I have to write down its formula. So mean equal sigma x multiplied by the probability of x. Okay, so I'm gonna start. The first x is 0 times the probability, which is 0.5. So I'm gonna multiply each x by its probability. Okay, now plus 1 times 0.2 plus 2 times 0.15 plus 3 times 0.1 plus 4 times 0.05, and then do the calculation. So the mean here it's going to be equal to 1. Okay, so the mean here is equal to 1. Now, what is the variance? Here you can apply both formulas. It's up to you. Now I'm gonna try to do the shortcut formula, which is sigma squared equal to x minus mu squared. So this is the original formula. The shortcut formula is sigma x squared multiplied by the probability of x minus the mu squared. You can apply the first formula, is totally fine, but let's try for now in this formula. So it's going to be 0 squared, which is 0, okay, multiplied by the probability, which is 0.5, plus 1 squared multiplied by 0.2 plus 2 squared multiplying by 0.15 plus 3 square multiplied by 0.1 plus 4 square multiplied by 0.05 and then minus the new square. The new is 1 square. Okay, then after doing the calculation, it's going to be 2.5 minus 1 square is 1, so it's going to be 1.5. So this is the variance. You can do it also by applying the original formula. It's totally fine. You will get the same answer. Okay. Now, the binomial distribution. There are 4 requirements for a binomial distribution. First, you have to apply to make sure all the requirements are met. So first, there are 2 possible outcomes. Since it's binomial, you cannot have more than 2 possible outcomes, and the outcomes are mutually exclusive, as either succeed or failure. Okay, so in coin experiment, I get head or tail. So if I am interested in head, so that means succeed. If I am interested in tail, then the tail is will be succeed and the head is failure. Okay, that's why I have only 2 possible outcome. Okay, so the number of trail is fixed and known. You should know how many times you will do the experiment. The possibility of succeed is the same for each trail. Each trail is independent of any other trails. Okay, so it should be independent, should be fixed and knowing. Okay, now the binomial probability formula that I have is probability of x is the combination between n and x by x multiplied by 1 minus pi to the power n minus x. Okay, so this is the formula of binomial probability distribution. C is denote a combination. N is the number of trial. As I said, in binomial, it should be fixed and known. X is the random variable defined as the number of succeed. Pi is the probability of succeed on each trial, and all of these should be given in the question. So let's say this example. A young family has 2 children, both boys. The probability of third birth being a boy is still 0.5. The gender of third child is independent. So since they have 2 boys, that does not affect the third gender of the third baby. So that's a good example of the binomial distribution. Now this is the formula. Let's say how we can do that. Now there are 5 flights daily from Pittsburgh. Suppose that the probability that any flight arrive late is 0.2. Okay, so now I have from the question 0.2, which is the probability that the flight arrive late. Okay, which is my pi here. Okay, and I have my n, which is 5 flights. So now, what is the probability that none of the flights are late today? None of flight, that means x equal to 0. Okay, so how I'm gonna solve it? I'm gonna find the probability when x equal to 0, because I'm gonna apply this formula. So it's the combination between n and pi and x. N here from the question is 5, x is 0, and the pi, as I said, is 0.2 to the power of 0, multiplying by 1 minus 0.2 to the power n minus x, which is 5. Okay, now I have to do the combination here. You can do it by hand, by like what we did in chapter 5, or you can do it by the calculator. So C multiplying 5, the combination between 5 and 0 is going to be 5 factor divided on 0 factor, multiplying by 5 minus 0 factor. Okay, then I'm going to multiply, I'm going to do the 5 factor, which is 5 times 4 times 3 times 2 times 1, divided in 0 factor, which is 1, multiplying 5 minus 0 is 5 factor, which is 5 times 4 times 3 times 2 times 1. So then I'm going to do by cancellation method, so it's going to be 1. Okay, so the combination between 5 and 0, it's only 1. Okay, as I said, you can do it by hand or you can do it by calculator. So it's going to be 1. 0.2 to the power of 0 is also 1. 1.0.2 to the power of 5, it's going to be 0.3277. So it's going to be 0.3277. So the probability that none of flight are late today is 0.3277. Okay. Now, second question, what is the probability that exactly one of the flight is late today? Exactly 1. Okay, that's mean I have to calculate when x equal to 1. So the probability of x equal to 1 is the combination. I'm gonna apply the formula. The combination between x, which is n, which is 5, and x, which is 1, and then the by 0.20 to the power of 1, multiplying by 1.0.2 to the power of 4. Why 4? Because it's 5 minus 1. Now I'm gonna solve it. The combination between 5 and 1, you can do it by hand or you can apply it in the calculator. So it's 5 factor, 1 factor, multiplying 5 minus 4 minus 1, which is 4. So minus 1. You can write like this or you can say it's 4. 4 factor. So it's going to be 5, 4, 3, 2, multiplying by 1 times 4, 3, 2, 1. So by cancellation method, this one is going with this. So the only remainder is 5. So the combination between 5 and 1 is 5. So I'm going to write it down. It's equal to 5 multiplying 0.20 because it's the power 1. 1 minus 0.2 to the power of 4. It's going to be 0.4096. And then after the multiplication, it's going to be 0.4096. Okay, so this is the probability that one of the flight is late today. Okay, how we can use no, we will use this. They will say the question use the binomial probability. Okay, now we have a shortcuts formula for the mean and the variance in binomial distribution. So the mean of binomial distribution is mean equal to n times pi. Okay, and also the variance is equal to n times pi multiplying by 1 minus pi. Okay, so this you will give them the question and they will ask you to find the mean and the variance. And be careful here because here is the binomial is different than the probability distribution. So now I use the previous example of flight into Bradford Airport, where n is equal to 5 and pi equal to 0.2. Okay, so the question asks to find the mean. So the mean is equal to n times pi. N here is 5 from the question, and pi is 0.2. So it's going to be equal to 1. The variance is equal to n by times 1 minus pi. So it's going to be 5 times 0.2 times 0.8. And then it's going to be 0.8. So this is the variance, okay, for the binomial distribution. Also, I would like to say we have a binomial probability tables. They are already tables. You can use them to find the probability. So the tables it looks like this. I'm gonna show you the tables like this. It's called binomial probability distribution. Okay, this table will help you to find all the probability from the question. So this example, see, in the southwest, 5% of cell phones call are drops. Okay, so I have 5% of cell phones call are drops. What is the probability that out of 6 randomly selected calls, none was a drop? What is the probability is exactly 1, exactly 2, exactly 3, exactly 4. So I'm looking for the probability of 0 up to 6. Okay, so I'm gonna find the table to show me that. So if in here is equal to 6, okay, so in here is the 6, which is the total of the number of tail, and then I'm gonna look to the 0.5% converted to decimal, so it's gonna be 0.05. Then I'm gonna look into the column, where is it? And the probability of exactly 0 is 0.735. Probability of exactly 1 is 0.232. Probability of exactly 2 is 0.031. So you can find the values from the table, from the binomial probability tables. In the questions, in the final, they will give you the tables to find the probability if the question wants to find it from the table. Okay. Also, we have the commutative binomial probability distribution. What we mean by commutative, it's in this example. So we're gonna look to this example to see how we can find the commutative binomial probability. So first, a study that Illinois Department of Transportation conclude that 76.2% of front seat occupied wore seat belts. Okay, that is both occupants of the front seat were using their seat belts. Suppose we decided to compare that information with the current usage. We select a sample of 12 vehicles. Okay, so we have to select the sample of 12 vehicles, and I wanted to see compare this with the current usage. So question one said, what is the probability that the front seat occupied in exactly 7 of the 12 vehicles are wearing seat belts? Okay, so the question said exactly 7. So now I'm gonna take my elements. So I have my n here, which is 12. Why 12? Because we selected 12. Okay, by is 76.2%. I'm gonna convert it to decimal, so it's gonna be 0.762. Okay, also I have my x, which is 7, because the question said exactly 7. Okay, so now I'm gonna apply the binomial formula, which is probability of x equal to 7. It's gonna be combination between n and x. Okay, multiplying by pi to the power of x, multiplying 1 minus pi to the power n minus x. Okay, this is the original formula. Then I'm gonna say probability of 7 is the combination between 12 and 7. The pi here is 0.762 to the power of 7, multiply 1 minus 0.762 to the power of 12 minus 7. I can write it 5. Okay, then I'm gonna calculate first how I can solve the problem. I'm gonna calculate first the combination between 12 and 7. Okay, you can do it by calculator, or you can do it manually. So it's 12 factor divided in 7 factor multiplied by 12 minus 7 factor, or you can say directly 5 factor. Okay, so it's gonna be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 4 3 2 1. Okay, 7 factor is 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factor is 5 times 4 times 3 times 2 times 1. Okay, this is how we do it manually. Then I'm gonna, by cancellation method, remove all of that, and 4 times 3 is equivalent to 12. 5 times 2 is equivalent to 10. So the remaining that I have is 11 times 9 times 8. So it's going to be 792. So this is the combination, the value of the combination here. Okay, so it's going to be 792. You can either do it by calculator or do it by hand. So then I'm going to write it down, the value of it. So it's going to be probability of 7 is equal to 792 times 0.762 to the power of 7 is going to be 0.149171 times probability of 1 minus the 1 minus 0.762 to the power of 5. If you do it in calculator, it's going to be 0.000764. Okay, then multiply all of these values together, then it's going to be 0.0902. So the probability that the front seat occupied in exactly 7, it's going to be 0.0902. Okay, so this is my answer. Now, if the question said, what is the probability that at least 7 of the 12 front seat occupieds are wearing seat belts? At least 7. And the lowest number is 7. So it could be probability of x greater than 7. It could be 7, 8, 9, 10, 11, 12. Why? Because the least number that I have is 7. So I have a greater number until 12. So it's going to be the probability of when x, the probability when x equal to 7 plus the probability when x equal to 8 plus the probability when x equal to 9 plus the probability when x equal to 10 plus the probability when x equal to 11 plus probability for x equal to 12. Okay, now how we calculate each of them? Remember here, probability of x equal to 7 is similar to this one. We calculate it in step number 1, in the question number 1. We calculate it. Okay, so I'm going to write down the value of it. So it's going to be 0.0902. So this is the probability of x equal to 7. I calculated in step number 1. Now, plus the probability of x equal to 8, you have to calculate it as we did in the question number 1. You will apply the same formula and substitute all the value. Then it's going to be your answer here, 0.1805. Okay, here's one. And then calculate for b equal to b probability, sorry, for x equal to 9, you have to do it as we did in step 1, and then it's going to be 0.2569. Probability when x equal to 10 is 0.2467. It's going to be 0.1436 plus 0.38. Okay, so this is the probability for all the values here. After you make a sum, it's going to be 0.9562. So this is the probability when I have at least of all the at least 7 of all the 12 parentheses occupied were really suitable. Okay, this is if this is follow the binomial probability. So the question should state that. Hopefully it's clear. Always try to do it each one and then make a sum. If the question said at least, if it said exactly 7, then only calculate for 7. So now let's see this example, this question. Now choose the correct answer from the following multiple choice questions. Okay, now consider a binomial distribution when n equal to 20 and by equal to 0.2. So the mean of the distribution is, first, what is the formula for the binomial the mean for the binomial distribution? The mean is equal to n times the pi. Okay, so in here, the question is 20 times pi, which is 0.2. So the answer is going to be 4. B equal to 4. Okay, so the answer here is 4. Now, consider a binomial distribution with n equal to 20, pi equal to 6. The variance of the distribution. Here, the question want to calculate for the variance. So it's equal to n times pi multiplying by 1 minus pi. N from the question is 20. Multiplying by the pi 0.6. Multiplying by 1 minus 0.6. After you do the calculation, it's going to be 4.8. So this is the answer. Okay, now in number 3, the question asks about the distribution. Okay, here is the distribution. This is not a binomial distribution. So now I'm gonna apply the first formula for the mean. Okay, so let's say I have this information. I have x equal to 4 and 5, 6, and 7. The probability of x, if it's x equal to 4, the probability is 0.3. Okay, 0.2, 0.1, and 0.4. So the question is ask find the mean. Okay, the mean is equal to sigma x multiplied by the probability of x. Okay, so it's going to be x here. The first x is 4 times 0.3 plus 5 times 0.2 plus 6 times 0.1 plus 7 times 0.4. So you only multiply the x by its probability. And then after you make a calculation, it's going to be 5.6. So it is B. Okay. Hopefully it's clear. Here in 3, the question didn't say it's binomial. Then I'm going to apply the formula of mean that we introduced at the beginning of this lecture. Let's see another example. The probability of an individual that is left-handed is 21% in a class of 30 students. Okay. Use the binomial distribution to find the probability that exactly 5 are left-handed. Round your answer to the nearest 100. So exactly 5 are left-handed. The size of my n here is equal to 30, total number. Okay, so how I can solve this problem. First, I'm going to identify n equal to 30, pi is equal to 0.21. I convert it to decimal, and my x here is 5. Okay, so I'm going to apply probability of x equal to 5. It's going to be the combination between 30 and 5 multiplying by pi to the power of 5 times 1 minus pi to the power of 30 minus 5, which is, I can write it 25. Okay, now what I'm going to do now is calculate this by calculator. So, and then substitute all the value by. So the combination between 30 and 5. By here is 0.21 to the power of 5. 1 minus 0.20 to the power of 25. And then calculate all of this value by calculator. Is going to be 0.161. Okay, so now this is my answer. So this is the probability. Okay, now what's the mean of the number of those who are left-handed? Here we're talking about binomial distribution. So the mean for the binomial distribution is equal to n times pi. So it's going to be 30 times 0.21 is going to be 6.3. See, what is the variance? So the variance here is going to be n times pi multiplying by 1 minus pi. So it's going to be 30 times the pi, which is 0.21, multiplying by 1 minus 0.21. So it's going to be 4.977. So this is the variance. Okay, just be sure it's the question said binomial. Then apply the binomial formulas for the mean, for the variance, or even the binomial formula. Okay. Okay. Wait. This is the tables for the binomial. If the question asks you to find it by tables, I'm gonna send this attached in the slide so you can look at it. So the last topic here in this chapter is called hypergeometric distribution. Okay, so when you're sampling from relatively small population without replacement, use the hypergeometric distribution. So we use this with a small population without replacement. So be careful here. So what are the characteristics for the hypergeometric probability experiment? Okay, an outcome of each step of an experiment is classified into one of two mutually exclusive categories: a succeed or a failure. So this is similar to binomial. Second requirement, the random variable is the number of succeed in a fixed number of a trail. Okay, the trail are not independent. So here is different than the binomial because it is not independent. 4, we assume that we sample from a finite population without replacement, and n divided by n is greater than 0.05. So the probability of succeed change for each trail. Okay, remember in binomial, the probability of succeed is the same for each trail. Here in hypergeometric, the succeed is different from each trail. Okay, so the hypergeometric distribution formula is probability of x, the combination between capital S and x multiplied by the combination between n, capital N minus capital S, and n, small n minus x, divided by the combination between capital N and small n. What do you mean by capital N and small n and s? We mean like this. So n is the size of the population. So it's the whole size. Okay? S, capital S, is the number of succeed in the population. Let's say I have a population of 3, a third student, that I'm interested only in the students who are succeed. Let's say I have 14 students succeed in my class. So S here is equal to 14. X is the number of succeed in the sample. Okay, so let's say I took from the 30 a sample of 20 students. Okay, X is the number of succeed in this sample. Okay, n small is the size of the sample. So n small here is equal to 20 because it's the size of the sample. C is the symbol for combination, as we took in chapter 5. Okay, so let's see, this is an example. I have this example. Okay, so playtime toy employ 50 people in assembly department. Okay, 40 of the employees belong to the union and 10 not. Okay, so first let me write it to make it clear. So I have 50 people, okay, in the union, in the assembly department. Okay, 40 of the employees belong to the union. So I have two groups. Okay, so 40 here belong to the union and 10 not. Okay, so this union and this no. Okay, now 5 employees are selected at random from the community. So I select a 5 random as a random, 5 employee as a random. Okay, so what is the probability that 4 of the 5 belong to the union? So what is the probability that 4 from the 5 belong to the union? So this is how it's work. Okay, now to understand which one is n, which one is small n, which one is the capital S, and all this stuff, let's start over again. Okay, so the question says 50 are in the assembly department. So my 50 here is the capital N because it's the whole population. 40 the employee belong to the union. So this is my 40 and this is my 10. 5 employees selected as random. So this is my N. Remember, small n is the size of the sample. Okay, now what are the probability that 4 of the 5 belong to the union? So the experiment here looking only for union. So my succeed here is union. So S here is equal to 40. Because the question said belong to the union. They want exactly how many, the probability that of selecting an employee belong to the union. So this is my succeed. 4 here is my X. Because the question asked about this probability. Okay, this is how we understand how we can organize our work. Now, I will set here N is 50, S is 40, small n is 5, and X is equal to 5. Okay, sorry, 4. And then I'm gonna apply the probability of X, which is 4. I'm gonna apply the formula for hypergeometric formula. So it's going to be the combination between S is 40, and X, which is 4. This is the first. Okay, and then it's combination between capital N minus 40, which is 50 minus 40, and small n minus X, small n, which is 5, minus X, which is 4, divided by the combination between capital N and small n, which is between 50 and 5. Okay, then I'm gonna solve for that. So it's gonna be the combination between 40 and 4, and between 10 and 1, and between 50 and 5. You can do it by calculator, or you can do it manually. If you do it by calculator, do each one separately. Do this one first, and this one's first, and this one first. Okay, do not put all of them in the calculator in case you are getting out of calculation. So now, the combination between 40 and 4 is going to be 91,390. And the combination between 10 and 1 is 10. The combination between 50 and 5 is going to be 2118760. And then after you divide it, it's going to be 0.431. So the probability that I will choose, and the probability that 4 of 5 is going to belong to the union is 0.431. Okay, this is how we solve it. Hopefully it's clear. Try first to organize your work, understand the statement, and then start to answer. Let's say this is a question. This is another example of this of hypergeometric distribution. So in statistic class of 30 students, okay, 30 students, 40 students are doing marketing and 60 are doing management. So if 5 students are selected at random, then use the hypergeometric distribution to find the probability that 3 of them are doing management. Round your answer to the nearest 1,000. Okay, so I'm gonna first try to understand the problem. So I have the total population, which is n equal to 30. Okay, from this 30, I have 14 doing marketing and 16 doing management. So I'm gonna like this. So I have 14 marketing and 16 management. Okay. Now, if 5 students are selected at random, so I have 5 students selected at random, so my small n is 5. So what is the probability that 3 of them, so 3 of them, that means x. So here x equal to 3. Okay, now let's say how I can determine my s. So the question said, what is the probability that 3 of them are doing management? So management here is my succeed area. So I'm gonna put s here is equal to 60. Okay, because the question interested in only students who are doing management. So I'm gonna apply n equal to 30, s equal to 16, small n equal to 5, and x equal to 3. Then I'm gonna apply the hypergeometric formula. So the hypergeometric formula is probability of x equal to combination between s and x, and the combination between n minus s and n minus x divided by the combination capital N and small n. Okay, then it's going to be the combination between 16 and 3 and the combination between 14 and 2 divided by the combination of 30 and 5. Okay, so it's going to be 0.358. Okay, so once you understand the values, how you can organize your work, then apply it in the formula. Okay, now let's see B. If the 3 students are selected at random, then use the hypergeometric distribution to find the probability that none is doing marketing. So the question is really interesting in the marketing. So here my S here is going to be 40. Okay, now if 3 students are selected at random, and here I have to change x, it's already 3. Okay, what is the probability that none is doing marketing? So x here is in here I have to make a small change. So here it said 3 students, then n is 3, the sample, and x here is 0. This is based on the question B. Okay, so I'm gonna start n equal to 30, s equal to 14, n equal to 3, sorry, x equal to 0. And then I'm gonna start apply the hypergeometric formula. So probability of x equal to 0, it's gonna be the combination between 14 and 0, and the combination between 60 and 3 divided by the combination between 30 and 3, so it's going to be 0.138. Okay, as I said, it's important first to understand the problem and then try to apply, try to substitute all the values. Let's say another example. The probability for a person to pass a written driving test is 90%. Okay, for a sample of 30 driver license applicants, first, use the binomial distribution to find the probability that exactly 25 pass the written test. Okay, exactly 25. So now, from the question, my n here is 30, pi is equal to 0.9, and x here is equal to 25. Okay, then I'm gonna start to solve it by using the binomial formula. The binomial formula is equal to the combination between n and x multiplying by pi to the power of x, 1 minus pi to the power of n minus x. Then substitute all the values. So it's going to be the probability of x equal to 25. So it's going to be the combination between 30 and 25, pi, which is 0.9 to the power of 25, multiplying by 1 minus 0.9 to the power of 5. So the probability is going to be 0.102. Okay. Now B, what is the mean? The mean is, since this is binomial distribution, so it's going to be n times pi. So n here is 30 times 0.9, so it's going to be 27. Now what is the variance? Again, it's binomial, so the variance is going to be n times pi multiplying by 1 minus pi, so it's going to be 30 times 0.9 times 0.1, so it's going to be 2.7. Okay. Okay, this is the end of lecture the lecture of chapter 6. Hopefully it's clear. The important thing is to know how to calculate the mean and the variance. If the question says binomial, then pay attention, because binomial has a different mean and variance. Also, we know how we can use the hypergeometric formula. Hopefully it's clear, and if you have any questions, just let me know. Thank you for listening. Hello everyone. Now we're gonna move to chapter 7. Chapter 7 is about continuous probability distributions. Remember in chapter 6 we discovered the discrete probability distribution, and this is the second type, which is called continuous probability distribution. We're gonna talk about the uniform probability. We're gonna describe the characteristic of the normal probability distribution. We're gonna talk about also the standard normal probability distribution and how we can use it to calculate the probabilities. So let's start with the normal probability distribution. The normal probability distribution is obviously a continuous distribution with the following characteristic. So it's a bell shape, as you see here. It's a bell shape. Has only one single peak at the center of the distribution. So it only has one peak at the center of the distribution. So this is the center which is mainly the mean. Okay, the distribution is symmetric. This is important. You have to always be careful when you see the normal probability distribution because it always has to be symmetric. The mean, median, and mode are equal. Okay, so the mean, median, and mode are all of them equal, and they are in the center of the shape. It's asymptotic, which is meaning the curve approach but never touch the x-axis. So here, if you see, it's approach the x-axis, but it's never touched it. Okay, it's completely described by its mean and standard deviation. So we describe this shape by mean and standard deviation. Usually in the question, they will give you the value of mean and the value of the standard deviation. So there is a family of normal probability distribution. Another normal probability distribution is created when either the mean or the standard deviation changes. So let's say this is the family of normal probability distribution. We have first, if we have equal means but different standard deviation, since they are equal mean, so the peak it's in the center here for all the shapes. As you see, the peak here, they on top of each other. Okay, since we have different standard deviation, so that's why they are in different height and in different shape. Now, if you have different means and standard deviation, so if they are different mean, that mean they are not on top of each other, as you see here. And also, obviously, the shape is different because we have different standard deviation. Now, if we have different means, okay, as you see here, but equal standard deviation, so they will be at the same height and the same shape because we have the same standard deviation. Okay, so this is the different type of the normal probability distribution. Now, the standard normal probability distribution, it's a particular normal distribution. So this is a special type of the normal distribution. It's unique, okay, because it has a mean of 0 and a standard deviation of 1. So this is by default. Always remember the standard normal probability distribution, the mean is 0 and the standard deviation is 1. This is always, okay? Now, we have another concept, it's called z value or z value. It's a sign distance between a selected value. So it's a sign distance between selected value designed with x and the mean mu, okay, which is divided by standard deviation. So we have a formula for z value, okay, which is z equal to x minus mu divided by standard deviation. X is the value of any particular observation or measurement. Usually the question will give you the x here and ask you to find the z value. The mu here is the mean, will be given from the question, and standard deviation also will be given in the question. Now, since they are standard, this is a standard normal distribution, the mu is 0 and the standard deviation is 1. Okay, this is because it's standard normal probability distribution. So the question either will say you have a standard normal probability distribution, or they will give you the mean 0 and standard deviation equal to 1. So it's depending on the type of a question. So let's say we have another concept, it's called the area under the normal curve. Okay, total area under the normal curve is equal to 1. Okay, so we have, this is okay, x-axis, and this is my normal probability distribution. All the area here, okay, it's equal to 1. Okay, now this is the mean, this is the mu. Okay, the part here is 0.5, which is half, and the part here is 0.5, which is half. This is by default. It's always true for all the normal probability distribution, even standard or normal, it's all the same. Okay, now we have an applications of standard normal distribution. It's very useful for determining the probability of any normally distributed random variable t. Sorry, for any random variable. The basic procedure is to find z. So first find z value, okay, based on the mean and standard deviation of its distribution. So the question will give you the mean and the standard deviation. Then, using z value, we can use the standard normative distribution and find the variance probability. Okay, so let's say this example. So this is the mean in the middle. Okay, the mean here is equal to 283. Okay, and the question asks you to find the probability when x equal to 285.4. So this is the value of x. Okay, I have the mean here, which is 283, and the question will give you the standard deviation and ask you to find z value. Z value is basically x minus mu divided by standard deviation, and we're gonna see this in example. So let's see this example. This is an example of standard normal probability distribution. In recent years, a new type of taxi service has evolved in more than 300 cities worldwide, where the customer is connected directly with the driver by via smartphone. It uses the Uber mobile application, which allows the customer with a smartphone to submit a trip request, which is then routed to a Uber driver who become the customer and take the customer to the desired location. No cash is involved. The payment for the transaction is handled by digital payment. So here for the center for the question, we all know Uber, okay? So this is a type of Uber, an example of Uber driver earning. So suppose the weekly income for Uber drivers who follow the normal probability distribution with a mean of 1,000 and standard deviation of 100. Okay, find the z value of income for a driver who earn 100. Okay, so this is the question asked about z value, and they give you the x here from the question. Okay, I have the mu, which is equal to 1,000, and I have the standard deviation, which is equal to 100. Okay, and the question asks about the specific value, which is my x. So z here is equal to x minus mu divided by standard deviation. So it's going to be 1,100 minus 1,000 divided by 100. So it's going to be 1. Okay, so this is the z value. Question 2, what is the value of income for driver who earns 900? So 900 is my x here. Okay, so I have the mu from the question, which is 1,100. It's 100. Sorry, 1,000 from the question here, and I have the standard deviation is 100, and my x, it's gonna be 900. So I'm gonna apply the formula z equal to x minus mu divided by standard deviation. So it's gonna be 900 minus 1,000 divided by 100. So it's gonna be minus 1. So this is the z value, okay, for this example. Now, regardless of where z is positive 1 or minus 1, the area under the curve is still the same because the shape is symmetric. So let's say, okay, this is my shape, okay, and the mean from the question is 1,000. Okay, here x is 1,100 and 900 is less the mean, so it's going to be in the left, so it's 900. Okay, remember the mean in the middle, and any number is greater than the mean, it's going to be on the right. Any number is less than mean, it's going to be on the left. Okay, so if you see here, the area here the area on the right, okay, here is equal to area here because it's symmetric. I only have the standard deviation from the mean to x is 100, and here is 100, so is the same. Okay, now can I find the area here? Yes, we can. We have a method to use which is called z tables. We're gonna see this. So see, before we see that, let's talk a little bit about the empirical rule. Empirical rule, as we know before in chapter 3, is that is stated that if a random variable is normally distributed, then for a symmetric bell-shaped frequency distribution, approximately 68% of the observation will lie within plus and minus 1 standard deviation of the mean. Okay, so this is the percentage, which is 68. It's going to be lie here in this area. Okay, it's going to be lie, let's assume the mean here. So the mean plus 1 standard deviation is going to be 110. The mean is minus 1 standard deviation, let's say it's going to be 90. So the area here, or the observation here is going to be 68%. Okay, now about 95% of the observation will lie within plus or minus 2 standard deviation of the mean. Okay, again, this area is going to be here. Let me change the color. It's going to be here. So all the area here is going to represent 95 of the observation. Okay, which is the mean plus or minus 2 standard deviation. Okay, now particularly 99.7% will lie within 3 standard deviation of the mean. Okay, again, it also represents this area and the whole area. So this, all these observations represent 99.7%. Okay, now how we're gonna see this in example? Let's see, we have an example here. So the empirical rule example, let me read it first. As a part of its quality assurance program, the O2 Light Battery Company conduct tests in battery life. For a particular DCL alkaline battery, the mean life is 19 hours. Okay, so this is my mean or my mu. So let me write it down. So the mu here is 19. The useful life, the battery follow a normal probability distribution. So you should see this word in the question, and then you understand that you have to use the table and all these. Now, with the standard deviation of 1.2, so the standard deviation here is 1.2. Okay, answer the following question. About 68 of battery have a life between what two values? Okay, what two values? Remember, we said before 68, it lies between mean plus or minus the standard deviation. Okay, so let's answer A. So it's lie between mu plus or minus 1 standard deviation. Okay, that's mean. The mu that we have is 19. Okay, plus or minus 1 multiplied by 1.2, which is the standard deviation. Then I'm going to solve it. 19 plus 1 times 1.2, so it's going to be 1.2. So it's going to be 10. Sorry, 20 is 19. So it's going to be 20.2. 19 minus 1.2, so it's going to be 17.8. Okay, so the batteries will fall between 17.8 and 20.2. So basically what you're gonna do is just calculate the mean and the standard deviation for 60, since it's 68%, then you have to add it or subtract only one standard deviation from the mean. B, it asks about 95%. We know before 95%, it's mean plus or minus 2 standard deviation. Okay, this is from the rule we took before. So it's going to be 19 plus or minus 2 multiplied by 1.2, which is the standard deviation. So it's going to be 19 plus 2 multiplied by 1.2. When you calculate it, it's going to be 21.4. 19 minus 2 multiplied 1.2. If you calculate, it's going to be 16.6. Okay, then 95% will be between 16.6 and 21.4. So these are the 5 the question asked about it. Okay, see, exactly the same, but here is 99. As you see, 99 is between mu plus or minus 3 standard deviation. Okay, so it's going to be 19 plus or minus 3 standard deviation, which is 21. Let's write it down. So 1.2, sorry, 1.2. So it's going to be 19 plus 3, 1.2. So it's going to be 22.6. 19 minus 3.1.2. So it's going to be 15.4. Then 99% will be between 15.4 and 22.6. Okay, so this is the full answer for this type of question. Okay, now this is the main object in this chapter, is to finding the area under the normal curve. Okay, now we have different scenarios to follow in order to find the area under the curve. Okay, so I'm gonna first walk you through these scenarios. Okay, but first we have to understand what is the tables, how we can calculate. I'm gonna describe this table in this example. Now, for the next application of the standard deviation of the standard normal distribution involve finding the area and normal distribution between the mean and a selected value, which we identify as x. Following the example solution will illustrate the details. So in the first example of Uber driver, we report that the weekly income of a ride-share driver follow a normal distribution with a mu equal to 1000 and standard deviation of 100. So A, what is the probability of selecting a driver whose weekly income is between 1000 and 1100? Okay, so I'm gonna first write it, try to understand the problem by, okay, draw. So the mu here from the question in the middle, which is 1000. A is what is the probability of selecting the whose weekly income between 1000 and 1100, which is going to be here. Okay. Now, basically, the question asks you to find this area. Okay. Now, this is the solution for A. So I have the mu here, and this is my x. So I'm gonna just write it down. The mu here is 100. 1000, sorry, and the standard deviation is 100. So Z, it's going to be x minus mu divided by standard deviation. So it's going to be 1100 minus 1000 divided by 100. So it's going to be, if you calculate that, it's going to be 1. Okay, now after I find the Z value, I'm going to go to the handbook the exam handbook that I sent to you. You're going to find this is the Z table. Okay, this is the Z, or the area under the normal curve. Okay, so basically you have a values of Z here, the Z, this is the value of Z, and this is the row here for the remaining number or the remaining digit. So now I have the value of Z is equal 1, which is basically 1.00. Okay, so I'm gonna find where is 1.0 from the table here. So this is 1.0. Okay, where is this 0? So it's gonna be here. The intersection here is gonna be 0.3413. So this is the area. Okay, this is the area when Z equal to 1. So I'm gonna write it here, the area here, or the probability when Z is between 1000 and between 1100, it's going to be 0.3413. Okay, so the area here, it's going to be 0.3413. Okay, so done with A. Let's say B. B, what is the probability of selected drive who earn less than 1100? So basically now, this is for A. Now for B, so this is the picture for B, just to understand the problem. So this is the mean. The mean here is going to be 1000. Okay, and the question said less than 1100. So this is 1100. Okay, now you will see it, since it's less, so it's meaning the whole area here. Okay, so it's meaning the whole area here. Now this is 1100. The less of this is going to be this area and this area. Now, as I said before, the shape here, the right part is equal to 0.5, and this is also the half, which is 0.5. So I know, since the question asks about all these parts, so I know by default this part is equal to 0.5. This part I have to calculate it, but I did in A here. So this part is equal to 0.3413. This is from part A. So basically the area under the curve is going to be 0.5 plus 0.3413. Why? Because we already calculated this area from A. So I'm going to add the half of the shape, which is 0.5. So the probability of Z is less than 1100. It's going to be 0.3413 plus 0.5, so it's going to be 0.8413. Okay, so this is how you can answer your question. I always recommend to just draw the picture to understand the requirement and then start to solve the problem. Okay, so this is the first scenario when the question asks to find a specific area here close to the mean. Since it's close to the mean, so only apply the Z formula and then look to the table and find the Z value. Let's see another example. Also refer to the first example of Uber driver. Find the probability that select a drive whose income is between 790 and 1000. Again, I'm gonna first understand the requirement. I'm gonna draw, okay? So the mean here from the question is 1000, okay? Now it said between 790, 700 is less than 1000, so it's gonna be here, 790 and 1000. 1000 is the mean. So basically the question asked me about finding this area. Okay, so now I'm gonna calculate the z value. So z here, it's gonna be x minus mu divided by standard deviation. X here, it's gonna be 790 minus the mu, which is 1000, divided by the standard deviation, which is 100. Okay, calculating that is gonna be minus 2.10. Okay, now I'm gonna go to the table, find minus 2.10. Now since it's symmetric, I don't have to look to the minus sign. I only have to look to 2.10. So I'm gonna go to the z table. Okay, now my z is equal to minus 2.10. I don't have minus in my table, so I'm gonna drop the minus and search for 2.10. So it's gonna be, I'm gonna look, where is 2.1? This is 2.1. Okay, and this is the column for z. So now it's gonna be 0.482. So this is the value, or this is the area under the curve, and using this z. So it's gonna be the probability of z is between 790 and 1000. It's gonna be 0.4821. Okay, so this is the solution for A. Now for B, I'm gonna try less than 990. So I'm trying to understand how can I approach the problem. The mean from the question is 1000, is less than 790. What is 790? It's gonna be here. This is 790. And they say less than. So I'm gonna look to the less than this value, which is here. Okay, now how I can approach the problem? I know this half of or this part. Okay, I know this part is equal to 0.5. Okay, this is from this is by default. Each half is equal to 0.5. Now, since I know that 0.5, I calculate the area here from A, which is 0.482. Okay, I calculate this part from A, and I know the total of this area is 0.5. So what I'm gonna do basically, I'm gonna take the total, which is 0.5, and subtract the area here to find the missing area here. Okay, so I'm gonna say the probability of z is less than 790. It's gonna be the total area, which is 0.5, minus the area that we calculate from A, which is 0.482. So the remaining is going to be 0.0179. So this is the answer. Okay, so the area here, it's going to be 0.0179. Okay, if you try to make a sum of this area, it's going to be 0.5. Okay, so this is the second scenario. Hopefully it's clear. Okay, let's see another scenario. This is a most common scenario also. When the question give you an area from the two parts of the shape. Let's say using the weekly income of ride-share drivers, weekly income follow the normal probability distribution. You should see this word with the mu equal to 1000 and standard deviation equal to 100. What is the area under this normal curve between 840 and 1200? Okay, I'm gonna try to draw to understand the question. Okay, the mean here is 1000 from the question. It's between 840, so is this the mean? So it's going to be in the left, 840, and 1200 is greater than the mean, so it's going to be on the right, 1200. Okay, so the question said, what is the area under this normal curve between? So the question asked me the area between these values. Okay, so the way to approach this problem is first calculate this area and then calculate this area and make a sum. Okay, so let's assume this area is Z1 and this area is Z2. Okay, I have to calculate each area and add them up. Okay, so let's say first the Z value of income for driver who earn 840. So this is Z2, sorry, let's say 1200, which is Z1. So Z1 is equal to x minus mu divided by standard deviation. X here is 1200 minus the mu, which is 1000, divided by 100, so it's going to be 2. Okay, so the area when the area sorry, so this is the Z1, which is the area between the mean and the 1200. So the probability that Z is less than 1000, sorry, greater than 1000 and less than 1200, which is here between these values, it's going to be, I'm going to look to the table when Z equal to 2. So this is the table. Okay, I'm going to find out when Z equal to 2. Let me clear it. So Z here equal to 2, which is 2.00, obviously. So 2 is here and 00 is here. So the value is going to be 0.4772. Okay, so I'm going to write down the table, the area here. So it's going to be 0.4772. Okay, so this is Z1. Let's find Z2, which is x minus mu divided by standard deviation. X here is going to be 840 minus 1000 divided by 100. So it's going to be, if you calculate, it's going to be minus 1.60. Okay, I don't have minus in my table, so I'm going to look to 1.60. Okay, now Z equal 1.60. So I'm gonna look where is 1.60. This is 1.6 and this is 0, so it's gonna be 0.4452. Okay, so it's gonna be here. The probability when Z is greater than 840 and less than 1000, so it's going to be sorry, 0.4452, which is the area between these values. And then, as I said, I find the area for Z1 and Z2, then I'm gonna make a sum. So the probability that Z between 1200 and 840, so it's gonna be Z greater than 840 and less than 1200, it's gonna be the sum of two areas. So 0.4772 plus 0.4452, which is 0.9224. Okay, always when you see this scenario or this picture, you have to make a sum between the two areas. So find the first areas and the second area and then make a sum. Okay, now we have a fourth scenario, is finding areas under the normal curve. Okay, what is the area under the normal curve between 1150 and 1250? Let's try to draw to understand the problem. Let's make it clear. So the mean also 1000. It's gonna be here the first x, which is 1150. The second x is gonna be 1250. Okay, and now the question asks you to find the area between this value. Okay, so how I can solve the problem? Okay, remember, always we will find the area if it's near the mean, but here it's not near the mean. So the way to approach this problem is first, okay, find the area between the mean and the largest value, which is 1250, and then find the area between the mean and 1150. So this is Z1 and this is Z2. So when you find this area, subtract them and then you will find the missing area. Okay, so this is the way how to kind of approach the problem, like similar to this. Okay, so let's say first we're gonna find Z1, which is x minus mu divided by standard deviation. My x here is 1250 minus the mean, which is 1000, divided by 100, which is the standard deviation. So it's going to be 2.50. Okay, so the probability that z is between or is greater than 1000 and less than 1250, it's gonna be from the table of z. So 2.5. So now my z here is 2.5. So I'm gonna look, this is 2.5 of 0, so it's gonna be 0.4939. So this is the area. So it's gonna be 0.4938. So we find Z1. Let's find Z2. Z2 is the area between the mean and 1150, which is my x. So it's going to be 1150 minus 1000 divided by 100. So the z value here is going to be 1.50. Okay, so the probability that z is greater than the mean, which is 1000, and less than 1150, it's from the table. So I'm going to look to the table. My z now is 1.5. 1.50. So I'm gonna look where is 1.50. So is this. So the area is 0.4332. So it's gonna be 0.4332. Okay. Now to find the missing area, as I said, I have to subtract z1 from z2. So the probability that z is between or is greater than 1150 and 1250, which is the desired area, it's going to be z1 minus z2. So it's going to be 0.4938 minus 0.4332. So it's going to be 0.0606. So this is represent this area. Okay, hopefully it's clear. Always try to memorize the steps, and this is how we usually do. We follow these scenarios. It's almost a similar idea, but of course you will have different numbers. You have this scenario and this scenario and this scenario and this. You have 4 scenarios. You have to follow them. Okay, now there is another scenario, which is that scenario in this chapter, is when the question asks you to find a value of x using z. Okay, so they basically will give you the value of z. Remember, the z formula is z equal to x minus mu divided by standard deviation. Okay, so they will give you the value of z, the value of mu, and the value of standard deviation, and ask you to find the x. This is easy. All you substitute the value and find the value of x. Another scenario, which is the scenario we use in this chapter, they will also ask you to find x with missing or unknown z. Okay, so we don't know what is the value of z. So you have to solve for 2 unknown here. Okay, so let's see how we can solve the problem like this. Now, Leighton Tire and Rubber Company wishes to set a minimum mileage guarantee on its new Max 100 tire. Test referral, the mean mileage is 67,900 with a standard deviation of 2,050 miles, and the distribution follow the normal distribution. Let X represent the minimum guarantee mileage and use the formula for Z to solve so that no more than 4% of tires need to be replaced. Okay, let's try to understand the problem. Okay, now the mean here is 67,900. Okay, now I have the minimum, which is 4%. Okay, this is the minimum. Since the minimum is represent 4%, so it's going to be here from the left because it's minimum, and this is represent 4% or 0.04. Okay, this is in decimal form. Okay, so now I know from the beginning of this chapter, this half of the shape is equal to 0.5. Okay, so to find missing area here, which is this area, to find it, I'm gonna subtract 0.5 from 0.04. Okay, because I still have 2 unknown here. If you write down the z formula, it's gonna be x minus mu divided by standard deviation. Z here is missing and the x is missing. The mu from the question is 67,900 divided by 2050. So I still have missing the x and the z. So first let's find z. Okay, so z here, I know the total area is 0.5. Oh, this is the area. Okay, so the area between mu and x, it's going to be 0.5 minus 0.04. So it's going to be 0.4600. Okay, so this is the area, which is this place. So 0.4600. So the area here, I'm gonna go to the table. So this is the tables. Okay, I'm gonna do it in opposite way. I don't have the z value. I'm gonna look to all the areas to find 0.4600 or the nearest number to this. Okay, so let's say I don't have from the areas here, so I'm gonna look here. Okay, so here I don't have 0.4600, but I have the nearest number here, which is 0.4599. Okay, which is here. Let's see. Which is here. So this is 0.4599, the nearest number to this number. So I'm gonna take this number, okay, and find the intersection. So it's gonna be here and here. So the number is gonna be 1.75. So z equal to 1.75. Okay, so here the z. So I'm gonna write it down. So z from the table, z is equal to 1.75. Okay, now my z is in the left side here. Okay, my z in the left side here, so it's going to be negative since it's in minimum and in the left side. So z is going to be negative, which is minus 1.75. Okay, so now I find the value of z. Then I'm going to substitute, okay, in z value. So it's going to be minus 1.75 equal to x, which is the missing, and the standard, the mean, sorry, is 67,900 divided by 2050, and then calculate all of that, and the x, it's going to be 64,312 miles. So this is my x's. Okay, always try to follow the same procedure in order to find or to understand the idea here. First, let's see if the question gives me the value of z. If the question gives me the value of z, so this is good. I only have to apply the last step. That's it. If I still, or if z is unknown, then I have to follow the same process. Okay. Try to understand the problem by draw the shape, and then look which area you have to calculate z for it. Okay, now let's say another example. So this is all about chapter 7. Let's say question 1. The mean score of ANSAT exam is 980. The standard deviation is 80. The score are normally distributed. What percent of the students score below 800? Okay, so let me draw to understand. Okay, this is x-axis. This is the shape. The mean here from the question is 980. What is the percent of students score below 800? So 800 is less than the mean, so it's going to be on the left, 800. Okay, the question said below 800, so the question asking me about this area. Okay, so I have to calculate for this area. So it's going to be probability of x less than 800. I'm going to apply z value. So it's going to be x minus mu divided by standard deviation. So it's going to be 800 minus 980 divided by 80. So it's going to be minus 2.25. Now, for this scenario, okay, let me write it down. For this scenario, I'm going to calculate this area because it's the area near the mean, okay? And then subtract it from the total, which is 0.5. Remember, the half here is 0.5. So I'm going to calculate this area because it's the only area I can calculate because it's near the mean. And then subtract from 0.5 to find this area. Okay, so I'm going to go to find the probability of z less than minus 2.25. So it's going to be from the table. Now, my z is equal to minus 2.25. I don't have minus, so I'm going to look to the 2.25. So this is 2.2, this is 5. I'm going to find where is it 5. So the intersection here is going to be 0.49. Sorry, it's 2.20. Oh, sorry. So it's 2.2. So this is 2.2. Okay. And then is 0.05. So the intersection here is going to be 0.4878. Okay. So I'm going to say the area is 0.4878. Okay, but sorry, this is z, yes, and then I'm gonna subtract this value, which is to say 0.5 minus 0.4878, so it's gonna be 0.0122. Now the question said, what is the percent? So you have to convert it from decimal to percent by multiply by 100, and it's going to be 1.22%. Okay, only convert it to percent if the question asks you. If the question didn't ask, just keep it decimal. Okay, let's say another problem. The new iPhone battery has an average surface life of 40 hours. Average is also the mean with a standard deviation of 2 hours. If the surface life of this battery is normally distributed, you have to see this word, then about what percent of distribution will be between 35 and 45 hours? Okay, let's try to understand the problem. It's the mean here is 40 hours. And it's between 35 and 45. So 35 is less than 40, so it's going to be on the left. 45 is greater, so it's going to be on the right. So the question is asked you basically to find the area between 35 and 45. And remember, we took the scenario before. Calculate Z1 and Z2 and then make a sum. Okay, so it's going to be the probability that 35 less than x, x greater than 35 and less than 45. Okay, so Z1 when x is equal to 45 minus the mean, which is 40, divided by 2. So it's going to be 2.5. Okay, and then area, it's going to be 2. So it's going to be z equal 2.5. So it's going to be here. So it's going to be 0.4938. So I'm going to write it down. 0.4938. Z2 is 35 minus 40 divided by 2. So it's going to be minus 2.5, and the area exactly the same, ignoring the minus sign. So it's going to be 0.4938. And then the probability that z is greater than 2.5 minus 2.5 and less than 2.5, it's going to be 0.4938 plus 0.4938, so it's going to be 0.9876. The question asks about percent, so multiply by 100, so it's going to be 98.76%. Okay, so this is the way how we can calculate that. Question 4, exactly similar to this question, the same idea. I have answered all the questions in the slide. Just go through all of them. Also, we have answered this. Now, here, find the area under the standard normal curve. If the question said standard normal curve, then assume mean is equal to 0 and standard deviation equal to 1. This is by default. Only when the question said standard. If the question didn't say, they will give you the mean and the standard deviation. So now it's by default, the mean is 0 and standard deviation is 1. So let's try to understand this problem. Now, z equal to 0 and z equal, so let's write it down. Draw the shape. And the mean is 0. And z1 is, z is 1.92. Okay, so I'm gonna basically find the area here. Okay, so z equal x minus mu divided by standard deviation. X here is 1.92 minus the mu, which is 0, and the standard deviation is 1. This is by default. Mu equal to 0 and standard deviation equal to 1. And then it's going to be 1.92. Then the probability that z is greater than 0 and less than 1.92, it's going to be from the table 1.9 and 2. Then section is going to be 0.4726. Okay, so it's going to be, I need to write it down. So it's going to be 0.4726. So this is the area. Here the question didn't ask about percentage, so keep it as decimal. Okay, all the questions the same procedure. Go through all of them. If you have any questions, just let me know. And for now, this is all about chapter 7. Hopefully all clear. Thank you for listening. Okay, hello everyone. Now let's talk about chapter 8. Chapter 8 is about sampling methods and the center limit theorem. It's basically in the end of the chapter, we're gonna apply what we have learned in chapter 7, but instead of doing that in population as we did in chapter 7, we will do that in a small sample of this population. Okay, so we have to do some changes to our formula, which is the formula, and then start to find the area under the curve. We're gonna see this later, but basically in this chapter we're gonna discover first the types of samples. So before that, why we have to do a sampling? Why we have to take a sample from a population? There's many reasons for doing that. So first of all, sometimes it's hard to estimate the value of the population parameter So it's saving time and money if you're doing this in sampling instead of the population. Also, it may be too time consuming to contact all member of the population. You know, sometimes we have a large amount of population, so we will waste our time if we try to contact each member of this population. But instead, if you're doing this on sampling, it will be much easier and saving time. It might be also it's impossible to check or located all the member of the population. Sometimes we have a different area. Like if you have talking about some population, you have to travel a long way. So it's too much hard to go to travel between each area, and sometimes it's impossible for any member to do that. So that's why it's easy to do this in sampling because it will be in the same location, for example. Now, also the cost of studying all the item in the population may be prohibitive. Okay, so this is some reasons why we have to conduct our study in sampling. Okay, so the probability sampling methods, we have four common types. We have simple random sample, systematic sample, stratified sample, and cluster sampling. So let's say simple random sampling. This is the most widely used method of sampling, um, which is a sample selected so that each item or person in the population had the same chance of being selected. Okay, so each member, okay, in this population has the same chance of being selected. Okay, example, let's say if there were 750 major eligible baseball players at the end of 2016 season. A committee of 10 players is to be formed to study the issue of consciousness to make sure every player has an equal chance of being selected. Okay, so the goal of this committee is to make sure every player has an equal chance of being selected. So basically, what they are doing is they write each name on the piece of paper, okay, place the name in a box. So they have a box, okay, and write each player name in the piece of paper, and they put it in this box, okay, and mix them up. Then draw 10 names, and then they select 10 names randomly. Okay, that's only to make sure that each player has the same chance to be selected. Okay, we call this method simple random sampling. It's simple. You have to write down all the name or all the different type that you have and then select it randomly. Systematic random sampling. Here, if you, we will do this method if we don't have a list of the entire population. Sometime in certain area, we don't have the entire list of entire population. Okay, to begin with. So then you can use the systematic random sampling, which is basically starting, which basically also is a random starting point is selected, and then every case member of population is selected. Okay, so you have to identify your starting point. Okay, so first identify a starting point, and then each member of the population is selected. Okay, for example, let's say we have a grocery store. And the grocery store want to study the length of time customers spend in their store. They know how much each member spend their time in the store. Okay, so they randomly selected the day of the week. So they select first which day, let's say in Sunday, for example, and they select the times, let's say morning. So this is the starting point. I don't have the name of our the list of any people who enter my store, but I can select the starting point, which is the day, Sunday, and I chose morning time, and then the starting point of the study. Then systematically select the customers and measure the time each spent in the store. Okay, so they will pick a customer. Okay, and this customer, they could measure how much time he spent in the store, and and if they wanted to do another study like behavior or something, so they will choose first the starting point. So only in systematic random sampling we will choose the starting point, and then each member has an equal chance of being selected. So I could choose this customer or this customer or this customer. There is no priority here. I only have to choose all the starting points. So this is basically how this systematic random sampling is work. Another type is called stratified random sampling. Okay, now here basically when the population can be divided into groups based on some characteristic, use stratified random sampling. So here population is divided into subgroups called strata, and a sample is randomly selected from each strata. Okay, so let's say I have a large group of population, then I'm gonna divide my population into subgroups. It's sometimes depended on some characteristic. Let's say, for example, now it's depending on the age. So here my age is, let's say, it's between 14 to 18. Here is between 19 to, let's say, 25. And here is between 25 and 30, for example. So I could divide my group population here into subgroups depending on some characteristic. Then a sample is randomly selected from each starter. So let's say I'm going to choose a sample from here, one person, and a sample from here, one person, and a sample here from person. So this is my randomly sample, okay? For example, a study of 50 of 352 largest US frames, and frames spending began with identify the starter, then use random sampling within each group based on relative frequency to collect the sample. So let's say the first starter, okay, is 30% and offer. Okay, second starter is between 20 to 30%. This is we divided our population in subgroups depending on some characteristic, and then this is how many numbers of each of one, and then the relative frequency, and then how many number of sample I could pick from each group. Okay, so this is basically how it's work. Now we have a last type of sampling, which is called cluster sampling. It's a common type of sampling which is used to reduce the cost of sampling over large geographic area. So this has to do some with geographic area. Okay, some here population is divided into cluster using naturally occurring geographic or other boundaries. Uh, People usually use the maps. Then cluster are randomly selected, and a sample is collected also by randomly selected from each cluster. So let's say I have a map here. Okay, I have different area. Then by random, I'm gonna select three geographic area. Let's say I chose Cork and Kenosha and Laporte. Okay, I select this by random, and then from each area, I'm gonna select each sample by random. Let's say I'm gonna select here 3% by random, and here 3, and here 3. So all of my my people selected randomly, and then this is my sample. Okay, as I said, this is commonly used over large geographic areas. Okay, okay. We finished from the type of sampling. Now we have a different concept. It's called sampling error. Sometime when we calculate the mean of a population, okay, let's say this mean is going to be mu is equal to 4, for example, and the sample of, or the mean of sampling, let's say, is 3.4, for example. Now I picked the sample from the same population, so it should be my mean the same. but sometimes you get a different mean. And in this situation, what we call is sampling error. Okay, so it's unlikely the mean of sampling will be exactly equal to the mean of population. So this is unlikely. It could be happen, but we always think about our sampling has the same characteristic from the population, and we have different mean. It's unlikely for us, and this is what we call it sampling error. Okay, how we can calculate the sampling error is the differences between a sample statistic and its corresponding the population parameter. Okay, sample statistic, which is the mean, and the population parameter, which is the mean. Okay, let's say now, what is the sampling distribution of the sample mean? Is a probability distribution of all possible sample mean of given sample size. Okay, now for a given sample size, the mean of all possible sample means selected from a population equal to the population mean. As I said before, sampling, if the sample is from the same population, okay, then it's equal to the population mean. Okay, how we can write that? So the mu is equal to mu, which is the mu of the mean of the sample. There is less variation in the distribution of the sample mean than its population distribution, because the mean is a small amount of the population. That's why it's clear that why the variation is less than between each value, the variation is less than the population. And the sample distribution of the sample distribution of the sample mean tend to become a bell shape. So as we said before, also, since we took the sample from the same population, and the distribution here is going to be also a bell shape. And here it's going to be our sample mean, which is X bar. And we're going to apply chapter 7 scenarios also here. Let's say this example. In this example, trade industry have been protection employee, the population. The hourly earning of each employee is given in the table. Okay, so this industry have 7 employees. Okay, Joy, Sam, Sue, Bob, John, Art, and Ted. And this is the hourly earning for each employee. So the question now giving you what is the population mean? Okay, now the question stated clearly the employee is the population. So what is the population mean, and what is the sampling distribution of the sample mean for a sample of size 2? 3. What is the mean of sampling distribution? And 4. What is observation can be made about the population and the sampling distribution? Okay, now the population is small, it's only 7 employees. Then we can calculate the population mean. How we can calculate the population mean, as we took this in chapter I think 3, it's sigma x divided by the number of n. Here is capital N because it's for the population. Then I'm gonna make a sum of all the hourly earning divided by the number of hours, the number of employee, which is 7 here, and the hourly earning is 14 plus 14 plus 16 plus 16 plus 14 plus 16 plus 18 divided by 7, so it's going to be 15.43. Okay, this is the mean. Now, what is the sample distribution of the sample mean for sample size of 2? So this is the type of a question when they ask you about the combination. Here in the question, the ordering here, or the repeating is not important. Okay, it's only ask you about how many different type I could make, or how many sample I could make for size of 2 employee. Okay, the total employee here is 7. and I wanted to check how many sample I could make with size 2. Okay, so I'm gonna apply the combination here between 7 and 2 to find how many sample I could create. So it's combination between 7 and 2. I'm gonna apply the formula in factor divided by n small factor, multiplying by n capital minus n small factor. So it's gonna be 7 factor, which is my n capital, divided by n factor, by 2, sorry, factors, multiplying by 7 minus 2 factor, which is 5 factor. So when you do that in calculator, it's going to be 21. Okay, so how many sampling I could create? I could create 21 sample from only 7 people. Okay, let's check that. So the first sample I could create, I'm going to choose Joy and Sam. Okay, this is the first sample. Second sample, I'm going to choose Joy and Sue. Third sample, I'm gonna check, I'm gonna make a sample from Joy and Bob, and so on. And when you do that, you will find out you have 21 sample of size 2. Okay, so first calculate it by the formula and then find out if the question asks you exactly to write down each sample. Question 3, what is the mean of the sampling distribution? Okay, the mean of sample distribution is asking about X bar. Okay, this is only if the question asks you about specific sampling, but here it's mu X bar. Okay, because we have 21 sampling. So I'm gonna calculate the mean of this 21 sampling. So I'm gonna first, how many sample mean who earning is 14? I have 3. How many sample mean earning is 15? Is I have 9. So I'm gonna multiply each of them. Okay, and then make a sum of all sampling mean. So it's gonna be 324. And then I'm gonna divide it by n, which is the total number of sample, which is 21. So it's gonna be 15.43. Okay, now you'll notice that the mean of the sampling is exactly the same as the mean of the population, which is the desired result. Okay, now what observation can be made about the population and the sampling distribution? The mean of distribution of the sample equal to the mean of population. The spread or the variation between the distribution of the sample mean is less than the spread in the population value. Of course, if, is obviously. As you see here, the differences between 14 and 15 is 1. Between 14 and 16 is 1. Between 14 and 17 is 3. So it's less than the population because the population I have larger than that. The differences between 14 and 18 is 4. So the variation here is bigger than in sampling. Also, the shape of population and sample distribution are different. As you, of course, see it here in the picture, the shape are different. Okay, so this is all about sampling and sampling error and how you can calculate that. Now we're going to move to the center limit theorem. Okay, so the center limit theorem, if samples of particular size are selected from any population, the sampling distribution of the sample mean is approximately a normal distribution. The approximation improves with larger samples. Basically, what does mean? If our population is follow the normal distribution, okay, that means also the sampling will follow also the normal distribution. Okay, this is from center limit theory, what it's about it. So if the population follow the normal probability distribution, then for any sample size, the sampling distribution of the sample mean will also be normal. Okay, if the population distribution is symmetrical, you will see the normal shape of the distribution of the sample mean emerge with the sample as small as 10. Okay, if the distribution is skewed or has thick tail, it might require a sample of 30 or more to observe the normality feature. Okay, now that's mean you have to have more sample in order to see also the normal distribution. Okay, and this is some example. So what is the central limit theorem conclusion? It concludes that the mean of the distribution of the sample mean will be exactly equal to the population mean if we selected all possible sample of same size from the population. So the mean formula is going to be like this. Okay, so the question usually will give you the mean of the population. Okay, let's say it's 20, and they will ask you about the random selected sample. Then you will say basically my mu is equal to mu x bar equal to 20. So the sample here is going to be also, the mean of the sample is going to be also equal to the 20. Okay, this is according to center limit theorem. Now, the standard deviation of the sampling distribution of the sample mean, it's also called the standard error of the mean. Okay, also the standard deviation will have another formula for sampling. It's going to be standard deviation of sample. It's going to be the standard deviation of the population divided by n square. Okay, there will be less depression in the sample distribution of the sample mean than the population, of course. This is obvious because it's sampling and this has a less element. So let's say this is an example. Or first, before the example, let's say how we can change the Z formula here. If the population follow normal distribution, the sample distribution of the sample mean will also follow the normal distribution for samples of any size. So this is important. I mentioned it before. If the population is not normally distributed, okay, the sample distribution of a sample will also mean will approach a normal distribution when a sample size at least 30. Okay, here if the population is not normally distributed, then the sample distribution of the same sample mean will approach a normal distribution when a sample size at least 30. So if I have a sample size more than 30, then I could approach the normality, even though the population is not normally distributed. Assume the population standard deviation is known. Okay, to determine the probability that a sample mean falls in a particular region, use the following formula. So this is our new Z formula. Okay, so Z equal X bar minus mu divided by standard deviation divided by n square. Okay, or you can divide this by standard deviation X and calculate this separately. So you have two ways to do it here. Okay, let's see this example. The quality assurance department for cola maintains recording regarding the amount of cola in its jumbo bottle. The actual amount of cola in each bottle varies a small amount from one bottle to another. Recorders indicate the amount of cola follows the normal distribution. So you should see this. Sentence. The mean amount of cola in the bottle is 13.2 ounces and the standard deviation is 0.4 ounces. This is for the population. Okay, this is for the population. And then you have another important sentence here. 16 bottles are randomly selected. If you see this, then we're going to talk about sampling. Okay, if you see this sentence, then we're going to talk about sampling. And the mean amount was 13.38 ounces. Okay, is this a likely result? Okay, it's unlikely the process is putting too much soda in the bottle is the same sample error of 0.18 ounces unusual. So let's say first we'll draw this as for population. Okay, so this is the mean and this is the mean, yes. And here is, the question said, is 30.38. Okay, and then they will ask you to see if this onset is unlikely result. So if I get bigger than this amount, this is mean unlikely result because they wanted to stay at the same amount each time. Now I'm gonna calculate the z first. So z is x bar minus the mu divided by standard deviation of x divided by square n. Now x bar is 31.38 minus the mu 31.20, this is from the question, divided by the standard, or the standard here, the population standard from the question is 0.04 divided by n square, which is how many randomly selected, which is 16. And then we calculate that is going to be 1.80. Okay, then I'm going to find out what is the probability that when what is the area under the curve when z equal 1.80. So let's say 1.80. This is 1.80. So it's going to be 0.4641. Okay, so the area here 0.4641, which is exactly this amount. Okay, now we conclude that it's unlikely. There is less than 4% chance the person is putting too much soda in the bottle. So if I get bigger than this, okay, if I get bigger of this, which is here, this is large. If I get bigger than this, that's mean it's unlikely. How we can calculate this area is basically I'm gonna take the total, which is 0.5 minus this area, which is 0.4641. This is from chapter 7. So it's going to be 0.03 0359. If you try to rounding, it's going to be 0.04. Now 0.04 is exactly 4%. So we have still a chance of 4% the person is putting too much soda in the bottle. Okay, so it's a likely result and we have to deal with it. Okay, now this is only an example. Let's say how you can, in the final, how you can see the the question about that. A household generate an average of 28 pounds on newspaper for garbage or recycle. Okay, this is an average. So this is an important information. Assume that the standard deviation is 4 bounds and the variable is normally distributed. So this is an important sentence, as I said before. So now this is my mu of population, and this is my standard deviation of population. Now, if 16 households are selected at random, so here an important sentence, 16 households selected at random. So now I'm gonna see this is chapter 8 because I have selected at random, and this is my n, small n. What is the probability that the sample mean of it generating is more than 30 pounds? Okay, now how we can answer this question? First, I'm gonna understand the problem by just make a shape. So this is my x-axis, and this is the shape. The mean here of the population is 28. Okay, and the question is generating more than 30 pounds. So 30 is greater than the mean, so it's going to be in the right. So this is 30, and the question said is greater than 30 pounds. So the question asking about this area. Okay, how we can solve the problem? First, I have to calculate this area and then subtract it from 0.5 because the whole this area is going to be half, which is 0.5. Okay, so my job is to find the probability that x bar greater than 30. Okay, now I'm going to apply the formula z equal x bar minus the mu divided by standard deviation of the population divided by square n. Okay, and then apply all the values. So let's write it here. Z equal the file x bar from the question is 30, the mean is 28, the standard deviation is 4, divided by n here is 16, which is the size of the sample. And then when you put it in calculator, it's going to be 2. Okay, so I'm going to find the probability that z is greater than 2 from the table. So I'm going to, first, what is the area when z equal to 2? I'm going to find it here. Z equal to 2 is here. So it's going to be 0.4772. So the area here is going to be 0.4772, which is basically this area. Okay, so as I said, I have this area and I have the total of this part, which is 0.5. So it's going to be 0.5 minus this area, 0.4772. And the remaining here is going to be 0.0228. So this is the remaining or the required result. Okay. Now the change I did here is the Z formula. Okay. When I have to use this formula when the question said are randomly selected. So whenever the question said it's randomly selected, I have to switch to chapter 8 formula of Z. Let's see this question. The owner of fish market determined that the mean weight for a catfish is 3.2 pound with a standard deviation of 0.8 pound. Assuming the weight of catfish as a normally distributed. So this is important. I see this. Now, for a sample of 25 catfish selected at random. So now I know I'm going to apply this Z formula because it said sample and select random. So now let's see how we can approach the problem. So first I'm going to draw the shape to understand. So the mean here is 3.2. Okay. And what is the probability that the sample mean of the weight is between 3.3 and 3.5? Whereas 3.3 is on the right of the mean because it's greater, and 3.5 is going to be here. So the question asks me to find this area. And we faced this scenario before. Okay, how I'm going to approach the problem? I'm going to first calculate the total area between the mean and 3.5. This is Z1. And then calculate the small area here between 3.3 and 3.2, which is Z2. And then make a subtract to find this area. Okay? So basically, my job is to find the probability of x bar greater than 3.3 and less than 3.5. Okay, now since it's selected at random, x bar is equal to mu x bar. Okay, which is here 3.2. Okay, so the mean here, this is mean, sorry, the mean here is equal to the mu of x bar, which is 3.2. Okay, why? Because we take this sample from the same population. Now, standard deviation of the sample is the standard deviation of the population divided by square n. You can do it like this, or you can use the formula. So z here is equal to x bar minus the mu divided by sigma divided by square n. Okay, now the values here, x bar, x bar is this is the formula for z. How we calculate z1? z1 is equal when x bar equal to 3.5, which is here. Okay, so z1 is 3.5 minus the mean 3.2 divided by the standard deviation, which is 0.08, divided by the sample size, which is 25. And then we calculate it, it's going to be 0.63. Then the area, I'm going to find the area here, which is 0.63. So this is 0.6. And this is 0.3. The instruction is going to be 0.2357. Oh, sorry, this is when you calculate, that's going to be 1.82. Sorry about that. And the area, it's going to be 1.80. So it's going to be 0.499. Okay, so this is the area for Z1, 0.4699. And then I'm going to calculate Z2 when x bar equal to 3.3. So it's going to be 35 minus 3 minus 3.2 divided by 0.8 divided by the sample size, which is 25. So it's going to be 0.63. And the area from the table, it's going to be 0.2357. Okay, so now the probability that z is greater than 0.63, less than 1.88, it's going to be z1 minus z2, which is 0.4699 minus 0.2357. So it's going to be 0.2342. Okay, so this is the answer. So this area, it's going to be 0.2342. Okay, it's exactly the same as we did in chapter 7, except that you have to change a z formula. Okay, let's see this example. The distribution of salary for a professional sports player is normal with a mean of $1.2 million and standard deviation of $0.7 million. Sorry. Suppose a sample here. Suppose a sample. So I'm gonna know this is a chapter 8. Okay. Also, it said is normal. Player was taking, find the probability that the sample mean of salary exceed $1.4. Okay, let's write first the problem to understand it. This is the x-axis and this is the shape. The mean of population is 1.2 and the question said find that the probability of sample mean salary exceed 1.4. 1.4 is greater than the mean, so it's going to be on the right. 1.4, it exceeds, so that mean is greater. So the question asked me to find this area. Okay, how? I'm gonna approach this problem. I'm gonna first calculate this area. Okay, let's call it Z, and then subtract it from the total, which is 0.5. Okay, so probability of x bar greater than 1.4, it's going to be z equal x bar minus the mu divided by sigma divided by square n. Okay, now let's say, what is the mu of the sample? As I said before, it's x mu, which is $1.2. Why that? Because the sample here is from the a population that normally distribute. That's why I have to say the sample also follow the population. So it's going to be 1.4 minus 1.2, which is the mean, divided by the standard deviation 0.7, divided by total number of sample, which is 15. So it's going to be 2.02. So I'm gonna find the area. So it's gonna 2.02. Sorry. Okay. So 2, and this is, so the instruction. Sorry, the instruction is gonna be 0.4783. Okay. So the area here is 0.4738, which is basically Z here. So this is the area of 0.4738. So now the probability that Z is greater than greater than 2.02, it's gonna be the total area, which is 0.5, the total half here, minus this small piece, which is 0.4738. So it's gonna be 0.0217. So this is the small part here. Okay, let's see another example. The age of book in the university library is normally distributed. So this is important, with a mean of 37 years and standard deviation of 10 years. Suppose that a random sample, so now I have to follow chapter 8 method, okay, is selected. What is the probability that a sample mean of age is between 30 and 33 and 42? So let's try to draw the shape to understand how I can solve the problem. Also, build shape. The mean here is 37. Okay. It's between 33 and 42. 33 is less than the mean, so it's going to be on the left. And 42 is greater than the mean, it's going to be on the right. This is 42. Okay. So the question asked me to find the area between these values here. Okay. So I'm gonna put this as a Z1 and this as a Z2, and then make a sum to find this area. Okay. Now, my goal is to find the probability that x bar greater than 33 and less than 42. Okay. My mu here is going to be the mu multiplying by x bar, which is 37, because also my sampling is follow the population, which is also normally distributed, and then z is equal to x bar minus the mu divided by sigma divided by square n. Okay, in here is 25. So I'm gonna first calculate z1. So it's going to be 42 minus the mean 37 divided by standard deviation, which is 10, divided by square of 25. So it's going to be 2.5. And the area, if you look to the table, let's look at the table, 2.5. 2.5 is going to be here, and the area is going to be 0.4938. Now Z2, when x bar is 33, minus the mean 37, divided by 10, divided by 25. And then we calculate it, it's going to be minus 2. Then I'm going to find the area. I'm going to ignore the minus 2. So this is 2. So it's going to be 0.4772. And then lastly, I'm going to find the probability of z greater than minus 2 less than 2.5. So it's going to be 0.4772 plus 0.4938. So it's going to be 0.9710. So this is my answer. So the area here, it's going to be 0. The area here between Z1 and Z2 is going to be 0.49710. Okay, hopefully it's clear. We still have some problem. I did answer all of them for you. Now the big important here in the end of chapter 8 is how we can distinguish the differences between chapter 7 and chapter 8. How I would know if the problem is I have to solve it depending on chapter 7, which is population, or chapter 8, which is sampling, because the procedure or the scenarios are the same, but you have to change the Z formula that you have to use. Okay, let's see this example. Question 1. The weight for adult males in Lebanon follow a normal distribution. So now I know this is a normal distribution with a mean weight of 173 pounds and a standard deviation of 30 pounds. If one adult male is randomly selected, so now there is a sign here, it's randomly selected. So this is a sample. What is the probability that his weight will be greater than 180? Okay, so now I have to follow chapter 8 because this is a sampling. So let's draw first the shape. The mean weight of the population is 173, and the question asked is greater than 180. 180 is greater than the mean, so it will be in the right. And since it's greater, so the question asked me about this area. So this is the required area. Okay, so now I have to find the probability that x bar is greater than 180. I know, since this is sampling, I know the mu here is going to be the mu multiplied by x bar, which is the same of the population, which is 173. Okay, I know also the standard deviation of the sampling. It will be the standard deviation of the population divided by n. You can calculate it separately or you can apply this in the formula. So I'm going to calculate z when x bar is equal to 180 minus the mean, which is 173, divided by the standard deviation of the sampling, which is the standard deviation of the population, 30, divided by a sampling, which is square 1. So it's going to be 0.23. Okay, so I'm going to find the area. of 0.23. So it's going to be here 0.0910. Okay, so the area is going to be 0.0910. Okay, so the probability that z is greater than 0.23, it's going to be 0.5, because the total area on the right is 0.5 minus the base here. We calculated. Remember, we find out the area of this piece, which is 0.0910. So 0.0910. Okay, it's going to be 0.409. So this is the desired area. Okay, hopefully it's clear. Is the important thing is if you see randomly selected or selected by random or anything or sign of randomly selected sample, so this is it when you have to follow chapter 8 method. Okay, question 2, the weekly income of foremen in the glass industry follow the normal probability distribution. So this is a sign of the normal distribution with a mean of 1000 and standard deviation of 100. What is the likelihood of selected freemen whose weekly income is between $950 and $1,100? The question didn't say it's randomly selected. Okay, didn't say anything about that. So now I have to follow chapter 7 method. Here, the question didn't say anything about randomly selected. So let's draw the shape to understand the problem. The mean here is 1000. Okay, and the standard deviation is 100. What is the likelihood of selected freeman whose weekly income between 950? 950 is less than mean, so it's going to be in the left. And 1100 is greater than the mean, so it's going to be on the right. So my goal is to find the area between these values. Okay, let's assume this one is Z1 and this is Z2, and I have to calculate this area and then make a sum. Okay, so let's see. First, mu is the mu from the question is going to be 1000, and the standard deviation is going to be 100. Z1 is x minus mu divided by standard deviation. This is the formula for Z from chapter 7. So it's going to be 1100 minus 1000. So this is the area here, divided by standard deviation 100. So it's going to be 1. And the area of when Z equal to 1 is going to be 0.3413. And then I have to calculate Z2, which is also x minus mu divided by standard deviation. So it's basically this area, and x here is 950 minus 1000 divided by 100. So it's going to be minus 0.5. And when you look at the table, the area of minus 0.5 is going to be 0.1915. So I find this area and this area, then I'm going to make a sum. So the probability that minus 0.5 less than the z and z is less than 1, it's going to be make a sum of this area 0.3413 plus 0.1915, so it's going to be 0.5364. Okay, so this is the desired area. So the big difference here is to understand when we have to apply chapter 7 method or chapter 8 method. Okay, I did give you many problems here. Try to do it, and I already solved it in the slide. If you have any question regarding any question of them, just let me know. So that's all about chapter 8. As I said, chapter 7 and chapter 8 almost or they have many of similarities, but try to understand the problem. If the question set is randomly selected, then you have to apply chapter 8 method. If the question didn't say anything about randomly selected, so then apply chapter 7 method. Okay, basically the difference is to use the formula, that's it. But all of the scenarios the same. Try to draw the shape to understand the problem and then start to solve. That's all, and hopefully it's all clear. And if you have any questions, just let me know. Okay, hello everyone. Now we're gonna talk about chapter 9. Chapter 9 is the last chapter in our curriculum. Hopefully it will be the easiest chapter for you. So it's basically about estimation and confidence intervals. Okay, so first let's um, get a sense what is the point estimate. A point estimate is a single value statistic used to estimate a population value with the parameter. Okay, so it's a value related to the sample and you wanted to use it to estimate the population value. Okay, the statistic compute the sample information that estimate a population parameter. For example, suppose the Bureau of Tourism for uh, Barbados wants an estimate of the mean amount spent by tourists visiting that country. Okay, they random select 500 tourists as they depart and ask these tourists about their spending while there. So they basically ask about 500 from people who about to leave the country and to ask them about how much they spent. The amount mean spent by the sample of 500 tourists serve as an estimation of the unknown population parameter. So basically, I could use the mean of this population and estimate the unknown population mean. Okay. Another concept is called confidence interval, which is a range value within which the population parameter is expected to occur. So it's basically, if you see this shape, so this is the mean, okay? If I said confidence interval, let's say I have the interval between this value, let's say x, and this value, let's be y, okay? So from x to y, this is the interval or the confidence interval that the mean will be occur within. Okay, so it's a range of values constructed from a sample data so that the population parameter is likely to occur within that range at a specified probability. The specified probability is called level of confidence. Okay, now the factor that determine the width of confidence interval for a mean are, we have three factors. One is the number of observation in the sample, which is n. Two is the variability in the population, usually estimated by the sample standard deviation, which is S. And three, the desired level of confidence. Okay, so we have three elements. We have to put it in consideration. Then we can determine the width of confidence. Okay, now I have a formula to calculate the level of confidence. The first formula is when the standard deviation is known. Okay, so the determinant of confidence limit when the population standard deviation is known, we use the z distribution. Okay, so if we know the standard deviation of the population, then we can calculate the level of confidence from this formula: x bar minus plus and minus z multiplying by the standard deviation divided by square n. Okay, x bar is the mean of the sample, Z, which is the value of particular confidence level, we find that from the table, and standard, which is the sigma here, which is the population standard deviation, and N, which is the number of observation in the sample. Okay, let's say this example. Now find the 95 confidence interval, okay, for Z. So if we wanted to find, this is the standard normal distribution. So if the question asks you to find 95%, okay, now if you see this shape, this is 0, which is the standard normal distribution. The mean is 0 and the standard deviation is 1. Now, if the question asks you to find 95% confidence, so it's going to be here, which is the whole this area. So the whole this area. How I can calculate that? I have many steps to do. Let's follow them. First, divided the confidence interval in half. Before that, convert this one into decimal, so it's going to be 0.9500, and then divide it into half, so divided by 2, it's going to be 0.4750. Okay, and then we're going to find this value in the body of the table, which is the table. So I'm going to go to the table. So this is the table. Just clear it. And then find, okay, find the 0.4750. Okay, 0.4750. So I'm gonna find out where is this exactly. So it is here. Okay, so it's gonna be this value and this value. So Z here is gonna be 1.95. So this is my Z. Now I put it, so the probability of find the value between Z, Z here, it's 1.96, and the probability of finding value between 0 and 1.96 here is going to be 0.4750, because this is the confidence interval. When we divide it into half, this is the right half and this is the left half. Okay, and also the probability for finding the value between 0 and 1.96 is the area here is 0.4750. Also the area between 0 and minus 196 also the same, which is 0.4750, because the shape is symmetric. Okay. Also, the empirical rule from chapter 7 is a great example of how to find the confidence interval, because it's divided in, as you see here, it's divided to 68% confident interval, the first interval, and then to 95%, which is the second interval, and lastly is 99.7%, which is the largest confidence interval here. Let's see this example. The American Management Association is studying the income of store managers in the retail industry. Okay, a random sample of 49 managers reveal a sample mean. So this is a sample mean, which is 45,420. The standard deviation of the population is 2050. So I'm giving here the standard deviation for the population. So now it's knowing, and I have X bar here. Okay, so how I'm gonna solve it? Now, what is the population mean? So now I don't know what is the population mean, okay? But we can use the sample mean as a best estimation, okay? We can use the sample mean, as we learned before, as a best estimation. So the sample mean, or use the sample mean, which is 45,420 as our best estimation or estimate. Okay. 2. What is the reasonable range of values for the population mean? Okay. Now, how we can do that? We're gonna yes. So the American Management Association decided to use 95% level of confidence. Okay. So we're gonna apply the formula, which is x bar plus or minus z multiplied by the standard deviation divided by square n. Now, okay, this is the formula. AMA, which is the shortcut for the American Management Association, okay, use 95% as a level of confidence. Okay. So I'm gonna apply this formula. X bar, which is 45,420 plus or minus. Now the 95% is in decimal is 0.9500. Okay, then I'm gonna go to the table and find where is 1 point yes, sorry, we calculate that. We calculate the 95% from here. Remember, we calculate it here, which is 0.4750, and then we find the z table, which is 1.96. Okay, so do the same steps here in order to find the z value. So z value here is going to be plus or minus 1.96, and then it's multiplied by the standard deviation, which is 2050, divided by square n, which is how many number is 49, manager here, and then calculate this part. So this one is going to be 45,420 plus or minus 574. Okay, so this is so now I'm going to calculate each of them. So it's going to be the interval here, so I'm going to calculate the confidence. So now the reasonable range is between, first I'm gonna make a sum, I'm gonna subtract for 575 from 45,420, so it's gonna be 44,846, and then make a sum, which is gonna be 45,420 45,994. Okay, so this is the confident or the reasonable value. Now 3, how do you interpret this result? Now we know the confidence value is between 45,846 and 45,994, and then the value, this value is called the margin of error. Okay, so how we can interpret this result? I'm gonna say this is the confidence interval and this is the margin of error. Okay, now what if we don't know the standard deviation of the population? How we can solve the problem in this category? Okay, now to determine the confidence limit when the population standard deviation is unknown, we use the distribution. Okay, we use the t distribution. We have a t table, so the t table is going to be here. So this is t table. Okay, we usually use it when the question didn't give you the standard deviation of the population, then you have to apply this method and use this table. Okay, this is called t table. Let's see how we can use it. This is the formula: x bar plus and minus t divided by standard deviation of the sample divided by square n. Okay, now a good example of that is the dean of business college will want to estimate the mean number of hours full-time student work at paying job each week. He randomly selected a sample of 30 students and asked them how many hours they worked last week. He can calculate the sample mean, but it's unlikely he wouldn't know the population standard deviation required for that. Okay, so he could calculate the standard deviation of the sample, but he will not, or he cannot calculate that for the population. Okay, so let's first discover what is the characteristic of the t distribution. It's a continuous distribution as a normal distribution. Okay, it's a monoid shape and symmetrical. It's flatter or more spread out than the standard normal distribution. Remember, standard normal distribution is less variation, but here is more variation. There is a family of t distribution depending on the number of degree of freedom. Okay, degree of freedom we present it as the df. This is called degree of freedom. Let's see how we can find the value of t. First, we have to assume the population is normal. Okay, and then we're going to use t table and then move across the column, identify for a confidence interval. So the question will give you the confidence interval, let's say is 95%, for example. Okay, then you have to find that. Okay, where is the column of 95? So this is the column of 95. In the next, and then calculate the degree of freedom. Okay, so then you have to let's say the degree of freedom, let's say n here is equal to 10. So the degree of freedom is going to be n minus 1, which is 10 minus 1. It's going to be 9. Okay, then find the 9 here, and the intersection with 95% is going to be your solution. Okay, let's see this in example to make it more clear. A tire manufacturer wishes to investigate the trade life of its tires. A sample of 10 tires driven 50,000 miles revealed a sample mean of 0.32 inch of tread remaining with a standard deviation 0.09 inch. Construct a 95% confidence interval for the population mean. Okay, would be reasonable for the manufacturer to conclude that after 50,000 mile population mean amount of tread remaining 0.3 inches. So let's see how we can do that. So first, I'm gonna apply the formula of x bar. Now x bar plus or minus t multiplied by standard deviation of the population divided on n. Okay, so now I'm gonna first find the t. Okay, let's say it's 95% confident interval. So t, I'm gonna calculate the degree of freedom. So it's gonna be 10 minus 1, so it's gonna be 9. Okay, how we can find t? I'm gonna go to find 95% degree. So this is the 95% degree. I'm gonna find degree of freedom, which is 9, and then the intersection is gonna be 2.262. Okay, so this is my t. So t here is gonna be 2.262. Okay, and then I'm gonna apply in the formula. So x bar from the question is gonna be 0.32 plus or minus t value, which is 2.262, multiplied by the standard deviation, which is 0.09, divided by square n, which is square 10. And then when we calculate the right part, it's going to be plus or minus 0.064. Okay, so the confidence interval are 0.256 and 0.384. So first you have to make a sum and then make a make a sum and then subtract. Now the question said what it would be reasonable for the manufacturer to conclude that after 50,000 miles the population mean amount of trade remaining is 0.3 inch. Okay, 0.03 inch is between my interval, is between this interval. So it will be reasonable that the mean of population is 0.3. So it would be reasonable because 0.3 is between my interval. It's between this number, actually. Okay, now let's say another example. A physician states that jogging in general increase the value of oxygen uptake. A sample of 11 joggers has a mean of 40.6 millimeters per kilogram and a standard deviation of 6 milligram per kilogram. Find the 90% confidence interval for the mean of oxygen uptake for joggers. Okay, now first, before start, I have to find t. So I'm going to calculate the degree of freedom, which is n minus 1. In here is 6, sorry, is 11th jogger. 11th jogger, this is the size of the sample, minus 1, so this is 10. Okay, and then 90% confidence interval. So t value from the table is gonna be, let's say, now I have to calculate. So I have 90%, okay, and the degree of freedom here is 10. So the intersection is gonna be 1.312. Okay, so t value 1.812. Okay, then I'm gonna apply the formula x bar plus or minus t multiplying by standard deviation divided by n. So it's going to be x bar is going to be 40.6, which is the mean of the sample, plus or minus t value, which is 1.812, multiplying by the standard deviation, which is 6, divided by square n, which is 11th. So it's going to be basically 40.6 plus or minus 3.28. Okay, so the confidence interval for the mean is between, so first is between 40.6 plus 3.28, and then 40.6 minus 3.28. So it's going to be, first it's going to be 43.88, and here is going to be 37.23, sorry, 32. Okay, so this is the interval, which is between 37.32 and 43.88. Okay, another example. A small business ships homemade candies to anywhere in the world. Okay, suppose a random sample of 16 orders is selected and each is weighted. The sample mean was found to be 400 grams and the sample standard deviation was 61 grams. Find the 90% confidence interval for the mean weight of shipped homemade candies, and how do you find an answer to the nearest 100 if needed. Okay, so now I'm gonna start by understand the problem. Suppose a random selected, so 16 here is my n, okay, and the sample mean was found to, so 400 is gonna be my x bar, okay, and standard deviation here is gonna be 61, okay, so this is not standard deviation, it's gonna for the population is s, which is standard deviation for the sample. Okay, and then first I'm gonna calculate the degree of freedom, which is n minus 1. N here is 16, minus 1 is gonna be 15. Okay, so 90% confidence interval, then t value is, so I'm gonna basically go to look to 90% with degree of 15, degree of freedom 15, so it's gonna be 1.753, 1.753. Then I'm gonna apply the formula x bar plus or minus t multiplying by standard deviation divided by n. Okay, so I'm gonna apply, so I substitute the value is 400 plus or minus 1.753 multiplying by 61 divided by 16. Okay, so the answer is going to be 400 plus or minus 26.73. Okay, so the confidence interval is between 373.27 and 426.73. Okay, let's see another example. The major store is interested in estimating the mean amount its customers spent in their first visit to the chain news store. 15 customers were randomly sampled. Their mean was $50.50, and the sample standard deviation was $10. What is the 95% confidence interval for the population mean amount is customers spent in the first visit to the chain news store? Okay, so now the 50.50 here is X bar, okay, and the standard deviation is 10 for the sample. And what else do I need to know is 15 customer. So here my n is 15. Okay, so first I'm gonna calculate the degree of freedom, which is 50 minus 1, it's gonna be 14, and then 95% confidence interval, then t value is gonna be, let's say the example, so here is 95%. Okay, degree of freedom is 14, so the answer is going to be 2.146. Okay, 2.14145. Okay, so I'm going to write it down. 2.145. So now I'm going to apply the formula x bar plus or minus t multiplying by standard deviation divided by n. So the x bar here is going to be 50.50 plus or minus 2.145 multiplying by 10 divided by 50, square 50. So it's going to be 15.15 plus or minus 5.54. Okay, so the confidence interval is between 44.96 and 56.04. Okay, so this is how you can calculate it in terms of we do know the standard deviation of the population. Okay, another topic is called confidence interval for proportions. Okay, what is the proportions is the fraction ratio or percent indicated the part of the sample of the population having a particular trait of this. So now I have a total number of sample, let's say 500, and I want to just to know the specific portion of this sample. Okay, I'm not asking about all the sample, I only ask about, let's say 100, for example. Okay, so we have to calculate a sample proportion B is founded by X, which is the number of succeed or the desired characteristic that I want, divided by the number of observation. Okay, so is the bar divided by the total. Let's see how we can calculate that. So the confidence interval for these proportions is identified by okay, and we have two requirements. First, the binomial conditions have been met. Okay, so I have to follow up with the 4 binomial conditions from the chapter 6. It has to be met, okay? And then the value in times the pi and n times 1 minus pi should both greater than 5. Okay, this is if I wanted to find the confidence interval. Okay, so we construct a confidence interval for a population proportion with the following formula. So the formula is b plus or minus z, okay, multiplying by square root b time 1 minus b divided by n. So this is our formula, and b is x divided by n, okay, from here. Don't forget that. Okay, let's say an example. The example said the union representing the bottle Bulwer of American BBA is considering a proposal to merge with Teamster Union. At least 3/4, okay, of the BBA membership must approve by merger. A random sample of 2,000 current members reveal 1,600 plan to vote for the marriage proposal. What is the estimate of the population portion? Can you conclude that the necessary proportion of BBA member favor to marriage and why? Okay, so first I'm gonna calculate the sample proportion. Okay, calculate sample proportion, which is B equal X divided by N. X here, which is the part 1,600, and the total N, which is 2,000. So it's going to be 0.80. Okay, now, and then applying the formula, okay, to find the 95% confidence. So the formula is B minus plus or minus Z square of B times 1 minus B divided by N. Okay, B here is 0.80 plus or minus Z. We calculate Z for 95 interval. Where is it? Yes, we calculate Z for 95 interval before, which is 1.96. Remember from this example, when we calculated here, when we calculate the 95, it was 1 point, let's see, sorry. Here, Z here is 1.96 when we calculate that as a 95%. Remember that, so we're gonna apply the same here. Okay, and then multiplying by square root, B here is 0.80 times 1 minus 0.80 divided by N, which is 2,000. So it's going to be 0.80 plus or minus 0.018. Okay, so the confidence interval here is between 0.782 and 0.818. Okay, so we can conclude that the merger will likely pass because the interval estimate include value greater than 75% of the union membership. Okay, so the interval here is greater than the 75%, so it's likely to pass. Okay, another example, when 400 college students are randomly selected and surveyed, it's found that 128 own a car. Okay, so how many total N is 400, and this the X here is 128. Find the 95% confidence interval for the proportions of all college students who own a car. Okay, first I'm gonna calculate my b, which is x divided by n. X here 128 divided by n, which is 400, so it's gonna be 0.32. Okay, now I'm gonna apply the formula b plus or minus z multiplied by b times 1 minus b divided by n. Okay, now I have to calculate the z and the z, which is 95% confidence. Okay, interval. Then z value is equal to 1.96. Okay, how we can calculate that? As I said, convert 95%, so it's gonna be 0.95, and then divided by 2, so it's gonna be 0.4, I think. Let's say 0.4750. Okay, and then go to the table, find this value, so it's gonna be z is gonna be 1.960. This is how to calculate the z. First, convert to the decimal, divided by 2, and then search for the table. Okay, so now z value is equal to 1.96. Okay, then apply the formula. It's gonna be 0.32 plus or minus 1.96 multiplying by 0.32 multiplying by 1 minus 0.32 divided by 400. So it's going to be 0.32 plus or minus 0.05. Then the confidence interval is between 0.27 and 0.37. Okay, this is how we can solve this type of problem. Now let's see another example. A quality control engineer is inserted and estimating the proportion of defective item coming off a production line. In a sample of 200 items, okay, 28 are defective. Using the 95% level of confidence, what is the confidence interval for proportion of defective item? Okay, so the question asks about all defective item. What is that 95% confidence interval? Again, I'm gonna start first by calculate the b, which is x divided by n. X is 28, total n, which is 200, so it's gonna be 0.14. Okay, and then 95 confidence interval, then z value, it's gonna be 0.95 divided by 2. This is how I calculate z value, 0.4750. Then from table, z value is equal to 1.96. Then apply the formula b. The formula is, it's b plus or minus z multiplying by b times 1 minus b divided by n. So b here is going to be 0.40 plus or minus 1.96 divided by the square root of 0.40 multiplied by 1 minus 14 divided by 200. So it's going to be, let's see, 0.14 plus or minus 0.048. Then the confidence interval is between 0.092 and 0.188. Okay, this is the solution. Now, how we can determine the sample size for the mean? Okay, how we can do that by a formula also. There are three factors that determine the sample size when we wish to estimate the mean. Okay, first, the margin of error, which is A. Two, the desired level of confidence. And three is the variation in the population. Once we know all of this information, you can calculate or estimate, you can calculate the sample size of the mean. Okay, so n equal to z times standard deviation divided by the margin of error, all square, all to the power of 2. So the power is not always the whole number. The usual practice is to round up any fraction result to the next whole number. Always here we have to round to the whole number. Let's see an example. A student in a public administration wants to estimate the mean monthly earning of city council member in a large cities. She can tolerate a margin error of 100 in estimating the mean. She would also prefer to report the interval estimate with 95% level of confidence. The student found a report by the Department of Labor that reported a standard deviation of 1000. What is the required sample size? So here basically we want to calculate the required sample size to know from the formula. So n equal z to standard deviation divided by the margin of error to the power of 2. So it's going to be z from the question, since it's 95 confident, so z here is 1.96. we calculate that before. Standard deviation, which is 1000, divided by the margin of error, which is 100. This is all given from the question, so it's going to be 19, sorry, this is to the power of 2, so it's going to be 19.6 to the power of 2. It's going to be 384.16. So this is the required sample size. Now, as we said, you have to round it to the whole number, so it's going to be 385. Okay, it's required to meet the conditions in the question. So this is the sample size. Okay, now how we can determine the sample size for proportion? Okay, now the first scenario here, it's for the population mean. Here is the for the proportions. Also, we have three factors we have to consider it. First is the margin of error. Okay, second is the desired level of confidence, and three is the value for pi to calculate the variation in the population. So here you have to apply pi, and the formula is n equal to pi multiplied by 1 minus pi multiplied by z divided by e to the power of 2. Okay, let's see an example how we can distinguish the differences. The students in the previous example also want to estimate the proportion of cities that have private refuse collector. The student want to estimate the population proportion with a margin error of 0.10. Prefer a level of confidence is 90% and has not estimated the population proportion. What is the required sample size? Okay, how we can do this like this. First, I'm gonna apply the formula n equal pi multiplied by 1 minus pi multiplying by z divided by e to the power of 2. Okay, first I have to find z. Okay, now z is the level of confidence here is 90%. Okay, converted to decimal, so it's going to be 0.90 divided by 2, so it's going to be 0.4500. Okay, so I'm going to look to the table, find that where is 0.500. It's going to be 1 point. So this is the nearest number to that, which is 0.495. This is the nearest number to my z value. So z equal to 1.64. Okay, then apply the formula by here, which is 0.5 equal to 0.5 because there is no estimation for the population property. So the chance of succeed is 0.5 multiplying by 1 minus 0.5, which is the chance of failure. Okay, multiplying by z value, which is 1.64, divided by the error, which is the margin of error, which is 0.10 to the power of 2, and then it's going to be 67.56. So this is the student need a random sample of 68. So this is, I'm gonna round it up. So the sample size, it's gonna be 68. So you have to round up this number. So it's gonna be 68. Okay, let's see this example. From a list of auto dealer, 50 were selected at random. Of the selected one, it was found that 20 washed the car after receive it. Find find a 95% confidence interval for the proportions of all auto dealer who wash the car after servicing. Sorry. Okay, so they wanted to know the confidence interval for that. So of course of proportions. So I'm gonna calculate the b, which is x divided by n. X from the question is 20 and n is 50, so it's gonna be 0.4. Okay, then 95% confidence interval. Okay, it's gonna be z equal 1.96. Why z equal 1.9? Again, as we did before, it's gonna be the 1.96 of z for z value. Okay, and then apply the formula p plus or minus z multiplied by p square of b time 1 minus b divided by n. So it's going to be the B 0.4 plus or minus 0.96, 0.4, 1 minus 0.4 divided by 50. So it's going to be 0.4 plus or minus 0.14. So the confidence interval is between 0.26 and 0.45. Sorry, 54. Okay, so this is the answer. Okay, so this is all about chapter 9. Hopefully all clear. It's only simple. You have to understand the problem and then apply the formula. And also it's attached the tables for Z and T table. That's all. Hopefully is clear. If you have any question, just let me know, and good luck in your final. Okay, now let's move to the final. The final will be on December 19, as you see in the university website. I think they'll be in the morning. So your final also, it's only 1 hour. So you only have 1 hour to do it. Hopefully the question will be much easier than the previous year because you only have 1 hour. Also, what other thing? Yeah, you can use your calculator during the exam. It's fine. You can bring it with you. Don't break any paper. All the formulas, the tables will you provide to you during the exam. It will come with the exam booklet. So this is a sample for the final exam. I tried to give you someone from the previous year. This one, it was in second semester last year, or actually this year. It was on, yes, April 23. I know this during the corona time, but hopefully it will give you the idea or the basic idea about the exam itself and the type of question you will see during the exam. Okay, now you will have 5 questions here. Okay, I don't know if they will reduce it, but at least they will reduce the difficulty of the exam. Also, when we go to the final pages, okay, see, this is in the back of your booklet, you will have the key formula. Okay, all the formula that you will need totally provided. This is from chapter 6, chapter 7, chapter 9, 8, chapter 9, all of them. Also, you will have the tables. This is the table and this is T table. Okay, so don't worry about that. It will be provided during the exam. For the key formula, please make sure to use the right formula. I know it will be provided. I won't ask you to memorize it, but at least you have to know which formula you should use to solve this problem. Okay, don't mix up between the formulas. Now let's start to do the first question. Okay, you have to do the declaration here. Now, the first question, it's worth for 20 points. Okay, so first, the number of mobile phones sold daily at X, Y, and Z electronics has the following probability distribution. So the number of mobiles sold and the probability of each X. So for X, you have 36, 39, 44, and 48 for the probability, as you see here. Okay, so we're talking here about the probability distribution. That's mean we're talking about chapter 6. Okay, now let's see. Question A, what is the mean of the number of mobiles sold in a given day? Okay, the mean here we have a formula for the mean from chapter 6 for the probability distribution. You either memorize it or you have to go back to your booklet and see where's the mean of the probability distribution. See, this is the formula. Let me clear it. So this is the formula. This is the mean of probability distribution. Okay, take this, put it in the question. You have to write the formula. If you miss or if you didn't write the formula, I will take 1 point for the formula. Okay, so make sure to write the formula, and then at least you will get 1 point if you like write wrong answer, for example. So let's see. I'm gonna first write the formula. So the mean, equal to sigma x multiplying by probability of x. Okay, so it's gonna be, I'm gonna take each x and multiply it by its probability and then make a sum. So it's gonna be 36 times 0.4 plus 38 times 0.2 plus 44 times 0.3 plus 48 times 0.1. Okay, so I did multiply all of them. So when I do it in calculator, okay, 0.1, it's going to be 40. So this is the answer. Okay, now if you see how I'm going to calculate for this question. So this question, okay, it's going to be worth for 5 points. Okay, I'm going to give 1 point for the formula. Okay, and then half for each component you write here. So here half, half, half. And if you give me the answer here correct, I'm going to give you 2 points. So if you calculate it, it's going to be 5. 1 plus my half and half and half, so it's going to be 5. If you write the answer like this, you'll get the 4 points. Okay, and this is how I correct this question. Please make sure to understand the procedure here. Now, let's go to solve the second problem. What is the variance of the number of mobiles sold in a given day? If you go to the also your booklet, okay, where's the variance formula? Okay, this is the variance of the probability distribution. I have this formula. I have 2 formulas, either this one or this one, and you are free to use which one do you like. Okay, only use one formula. You don't have to use both because you'll get the same answer. So choose one and do it for the question. Okay, let's see. I'm gonna pick this formula. Variance equal to the sigma x time. Sorry. I'm gonna pick this formula. Variance equal to sigma x minus mu square times the probability of x. Okay, now the mu is equal to 40 from A. I have the mu from the previous answer. Now, if you get the mu wrong here, then all your calculation is going to be wrong. So be careful. So it's going to be, I'm going to substitute all the value. So the first x I have is 36 minus the mu, which is 40, times the probability, which is 0.4. This is the first component, done. And then plus second component, x2 is 38 minus 40, sorry, 44, no, 40, sorry, the mu is 40, times the probability, which is 0.2, okay, plus 44, which is x3, minus the 40. The probability of x3 is going to be 0.3 plus 48 minus 40 times 0.1. So if you calculate all of these, it's going to be 18.4. Okay, now I'm going to correct the question. The question worth 5 points. Okay, so I'm going to give 1 point for the formula, half for the first component, half for the second component, and half for the third, and half for the fourth, and then the answer itself is going to be 2. So all of your grade is going to be 5. Okay, so be careful. Now let's go to the B. B, a pharmaceutical company claims that a new drug is effective against some infections. Infection disease is 80% of the time. The drug is tested on 48 selected patients. Okay. A, use the binomial distribution to find the probability that exactly 32 patients recovered from the infection disease. Round your answer to nearest 1,000. Now, do I have a formula for the binomial distribution? Yes, I have. If you go here, from the question, you will find out the formula. It's here. This is the binomial distribution. So use this formula. Okay, so let's go back and try to answer. Okay, so the binomial distribution formula is the probability. It's going to be the combination between n and pi times pi to the power of x multiplying by 1 minus pi to the power of n minus x. Okay, now what is n? N is the size, or it's the size of the sample. It's tested on selected 48. So this is my n. What is my x? X is the sample. Okay, this is my x. And the question asked me. Okay, so I'm gonna substitute all the value. So it's gonna be the combination between n, which is 48, and 32. The pi, which is the percentage here, you have to convert it to decimal, so it's going to be 0.80. Okay, so it's 0.80 to the power of x, which is 32. Okay, times 0.2, which is, what is 0.2, by the way? I can write it like this, just to, I don't want to get you confused. It's 1 minus 0.80 to the power of n, 48 minus 32. Okay, so it's going to be the combination between 48 and 32, 0.80 to the power of 32 times 0.2 to the power of 16. Okay, you can first solve this by the calculator, or if your calculator is advanced, you can do it by one step. Just make sure to write the correct answer, and then if you solve it, it's going to be 0.0117. Okay, just round it to the nearest 1,000. Okay, to the nearest. Yes, you can write it like this or round it if you want. If you round it here, it's going to be 0.012. Okay, now how I'm going to correct this answer. This answer is worth for 4 points. Okay, here is 4 points, 1 point for the formula. Okay, and 3 points for the final answer. If you round it wrong, if this round is wrong, I'm gonna take half points. Okay, If you put a round wrong, I will, sorry, if you put a wrong round, I'm gonna take half a point. Okay, this is how I correct this answer. Now let's say B, what is the mean of the number of patients who recover from that infection disease? The mean for binomial, the formula, you can look to the back, or if you memorize it, is mean equal to n times pi. Okay, now n is 48, and the pi from the question is 0.8. If you multiply, it's going to be 38.4. Okay, how I correct the answer? I'm gonna give you 1 point for the formula. Okay, 1 point for the formula, and 2 points for the answer. Okay, this is 3 points. Now, what is the variance of the number of patients who recover from that infection disease? The formula for the variance, you can look back and you see it, is this is for the variance of binomial. Don't mix up between this formula and this formula. This is the probability distribution here, but here the mean of the binomial. So this is the variance. Okay, so this is the value, so it's going to be 7.68. Now, how I'm going to correct this answer? I'm going to give you 1 point for the formula and 2 points for the final answer. Or I'm going to give you 1 point and here 1 point. It depends. If you give me the correct answer, I'm going to give 2 points. So here is 3 points. Okay, total for the first question is 20 mark. Okay, hopefully it's clear. Now let's see the second question. Suppose a researcher goes to the small college of 200 faculty, 12 of which have a blood type O negative, A minus negative. He obtained a simple random sample of n equal to 20 of the faculty. Let the random variable x represent the number of faculty in the sample size who have blood type O negative. What is the probability that 3 of the faculty have blood type O negative? Round your answer to the nearest thousand. B, what is the probability that none, x equal to 0, of the faculty has blood type O negative? Okay, now how I'm gonna solve this problem? This is an example of hypergeometric distribution. Okay, now first, the population here is 200. So I'm gonna solve it like this. Change the color. So it's 200. Okay, of which 12 of which have a blood type O negative. Okay, so from the 200, I have 12. Okay, who have O negative, and I have the rest of the 12, which is 100, I think 80 something. Let me see. 188. Okay, and the question, what is the probability that 3 of the faculty who has O negative? Now, I took a sample from both category, which is n equal to 20. Okay, and then here x is changing depending on the question. Okay, now in A, what is the probability that 3 of the faculty who have blood type O? So here 3, which is my x. Now, from the question, okay, what is my S? The question asks me who have blood type O negative. So that's me. My S is 12. I'm gonna go here because 12 already I know from the question they have blood type O negative. Okay, the rest no. So the question asked me about that. So my S here is 12. So I'm gonna organize my work. So here, capital N is 200. Okay, capital S is 12, n, small n, which is 20, x is 3. Okay, so now this is only organize my work. So now I'm gonna write the formula. The probability here of the, you can look back and write it. Since I'm saving, I'm gonna write it. Okay, so the probability here is gonna be the combination between s and x, okay, times the combination between n minus s and n minus x divided by the combination between capital N and small n. Okay, I'm gonna substitute the value. So it's the combination between s here is 12 and x is a 3. Here n minus capital N minus s is 180, and n minus x, which is 17. Okay, divided by the combination between capital N, which is 200, and small n, which is 20. Okay, now try to answer it in the calculator. So first take this component and put it here, and then the second component, or you can do it by one step. It's up to you, but just make sure you enter the correct answer, and then if you do it, the final answer is going to be 0.0833. Okay, now the question asks you to round your answer to the nearest thousand, so it's going to be 0.083. This is to round your answer. Okay, now I'm going to show you how I correct this answer. So for the formula, I'm give 2 points. Okay, from the substituting the value here and here, I'm going to give you 5 points. Okay, final answer is 3 points. And if you put a wrong round, I'm gonna take half point. Okay, but this is only if you give me a wrong round. Now this question is worth for, I think, 10 points. Yes, this is 10 points. Okay, now let's go to the B. B, what is the probability that none? So x equal to 0 here. So I'm gonna change here. X equal to 0. Okay. So now it's have none. So my s here also is gonna be changed. Okay. Let's see. What is the probability that a none x of the faculty has blood type O negative? Okay. So still here, the question wants has blood type O negative. How many faculty I have? I know that they have O negative. I have also 12. So my is still the same in B. So I'm gonna write all the value. N equal 200, S equal 12, N small is 20, and X equal to 0. Okay, so I'm gonna also write the formula again. So the probability equal to the combination between S and X, and the combination between N minus S and N minus X, divided by the combination capital N and small n. Okay, substitute all the value. So it's going to be 12 and 0. It's going to be 180 and 20. And it's going to be 220. Okay, so the answer is going to be 0.728. Okay, how I'm going to correct it? So this question is 5 points. So I'm going to give you here 1.5. Okay, and I'm going to give you 3.5, for example. For the formula, I already gave here, so there is no, I mean, if you write the formula, you will get a point, but this is depend on the correcting. Okay, because sometimes I have to follow the correcting form. So if they say only give the point for one time formula, so I'm gonna give it here, so there is no point here. Okay, now let's go to other question. The volume of juice in bottle from a particular production line is normally distributed with a mean equal to 480 milliliter and standard deviation of 12.5 milliliter. What is the probability that a randomly selected bottle will contain more than 445 milliliters of juice? Double I, what is the probability that a randomly selected bottle will contain more than 510 milliliters of juice? Triple A, what is the probability that a randomly selected bottle will contain between 467.5 milli and 492.5 milli of juice? This is a direct question from chapter 7. Okay, how I'm gonna solve it? Let's see. First, I'm gonna draw to understand the problem. Okay, so here, let's see. I have this shape. The mean here from the question is 480. The standard deviation is 12.5. Okay. A, what is the probability a selective will contain more than 445? Where is 445? This is the mean, so it's going to be here. This is because it's less than mean. The mean is 445. Okay. Now the question said, what is the probability will contain more than? So basically the question wanted to know this area. Okay, how I'm gonna solve it? Let's see. So first I'm gonna find the area for this this portion and then added it to 0.5 here. Why? Because all the portion here is gonna be 0.5. Okay, but I don't know exactly what is the area for this portion. So I'm gonna first solve for it and then added it to 0.5. Okay, so let's see how we can do that. So my goal is to find the probability that x greater than 445. Okay, so I'm gonna write the z formula. Now in this question, it didn't talk about sample. It only talk about the population. So now I will know I'm in chapter 7. Okay, so I'm gonna use the z for chapter 7. X minus mu divided by standard deviation. So it's going to be 500, it's going to be 445 minus the mu 480 divided by standard deviation 12.5. Okay, so if you calculate it, it's going to be minus 2.8. Okay, now I'm going to find the area. I'm going to write the area here. Okay, I'm going to go to the table, 2.8. This is my z table. Now z here is equal minus 2.8. So I'm going to find out what is here. So this is the area, 0.4974. So the area is going to be 0.4974. Okay, so now I'm gonna find out the probability that of z greater than 2.8. Why is it greater? Because this is the area for, or this is the value of z here, which is 0.2.8. So I'm gonna find all the area greater than this. Okay, so it's greater than z equal minus 2.8. So it's going to be the right area, the total right area, which is 0.5, plus the portion that we find the z value at, which is 0.4974. If you make a sum, it's going to be 0.996. 467.4. Okay. Now, if you write the answer like this, you'll get a full point. Okay. How I'm gonna correct the answer? This is worth for 6 points, as you see here. This is 6 points. First, I'm gonna give 1 point for the formula and 1 point for the answer. So the formula here, okay, I'm gonna give 1 point. And the answer is 1 point also. Okay. Also, I'm gonna give the area 1 point. Then I'm gonna give here 1 point, 1 point here, and 1 point here. So we'll get 6 points here. Okay. Now let's see the second question. What is the probability that a randomly selected bottle will contain more than 510 milli of juice? I'm gonna draw the problem to understand. The mean is 480, and the x here is 510, so it's going to be on the right here. Now it said contain more, so more is going to be here. Okay, so I'm gonna my aim is to find the probability of x greater than 510. Okay, now this is my goal. Okay, now I'm gonna use z is equal to x minus mu divided by standard deviation. It's going to be 510 minus 480 divided by 12.5. So if you calculate, it's going to be 2.4. If you go to the z table, you will find the area. It's going to be 0.49180. Now to solve this problem, okay. Now you will notice we are all the area is only on the right. Okay, I know the total area on the right is 0.5. I have this portion. So to find this portion, I'm gonna make a sum. The z that I calculated is here. This is z value. Z value is 0.4918. Okay. To find this portion, I'm gonna subtract the total from this portion that I found. Okay. So it's gonna be the probability of z greater than 2.4. Z is greater than 2.4. It's going to be 0.5, the total area, minus the area that I found, 0.4918. So it's going to be 0. Let me change the color. Sorry. Just I need to see the grade. So the probability that z is greater than 2.4, it's going to be 0.5 minus 0.4918, which is the area I found. It's going to be 0.082. Okay, how I'm going to correct this question? This question is worth for 6 points. Again, I'm going to put 1 point for the formula, 1 point for the solution, and 1 point for the area. Also, I'm going to put 1 point here, 1 point here, and 1 point here. Okay, so be careful. Now, let's see the other question. What is the probability that a randomly selected bottle will contain between 467.5 and 492.5? So I'm gonna draw to understand how I can start. Okay. By the way, this is an additional step. You don't have to do it if you can solve. Okay. Now, the mean is 480. My first x is below the mean, so it's gonna be here, 467.5. And is greater than the mean here, so it's going to be 492.5. So my goal is to found the area here. Okay, so my aim is to find the probability of x. Okay, x is greater than 467.5 and less than 492.5. Okay, this is important. You will get 1 point for that. And now I'm gonna put the Z formula, x minus mu divided by standard deviation. It's gonna be, oh sorry, this is Z1. So now I'm gonna say this one is Z1 and this one is Z2. So I'm gonna solve for Z1 here, and this is Z2. Z1 is between 480 and 492.5. So my x here is 492.5 minus the mu 480 divided by 12.5. So it's, if you calculate it, it's gonna be 1. Okay, and the area here, if you go to the Z table, is 0.3413. Okay, Z2 is x minus mu divided by standard deviation. So it's going to be x is here 467.5 minus the mean 480 divided by standard deviation 12.5. It's going to be minus 1. And the area, if you go to the Z table, it's going to be 0.3413. Okay, now I have the area on the right and I have area on the right and area on the left. So I'm gonna make a sum. So the probability of that Z is greater than minus 1 and less than 1, this value, it's gonna be 0.3413 plus 0.3413, so it's gonna be 0.6826. This is the full answer that I'm looking for. Now, how I'm gonna correct that? Here 1 point, okay, and the formula here also 1 point, okay. You will gonna have here 1.5, okay, and here 1.5 if you give me this answer, and then here 1 point, 1 point, and here 1 point. Okay, so 1 plus 1 is 2 plus 3, 5, 6, 7, 8. So now it's 8 points. Okay, hopefully it's clear. This is a direct example from chapter 7. Now let's see. Now let's go to the question 4. Question 4 is a great question to understand the differences between chapter 7 and chapter 8. Okay, the average cost to rent a full-size car is 64 per day. Assume that this rental cost follow a normal probability distribution and that the standard deviation for this population is 4.6. Okay, what is the probability that a randomly selected full-size rental car costs less than 60? Okay, B, if the sample of 9 full-size rental car is selected, what is the probability that the sample mean is more than 70? Now, if you see here the difference, what is the probability that a randomly select full size? It didn't talk about sample here. There's no sample word here. So here is chapter 7. Okay. B, if a sample, here's a sample. You see a sample word. So here is chapter 8. Okay. Now, let's see to see A. I'm gonna draw. The mean here is gonna be 64. Okay. Now, is less than 60. So 60 is less than me, so they're gonna be on the left here. And it's less than 60 here. So I'm looking to this area. Okay. How I'm gonna solve that? I'm gonna first find the area here and then subtract it from the total, which is 0.5, because the total area on the left is 0.5. So I'm gonna find the probability that x less than 60. This is the aim. Okay, and then Z formula is gonna be x minus mu divided by standard deviation. Now x here is gonna be 60 minus the mu, which is 64, divided by the standard deviation, which is 4.6. If you calculate that, it's going to be minus 0.87. If you go to find the area here from the table, it's going to be 0.3078. Okay, now my answer, probability of z less than minus 0.87, it's going to be 0.5 minus 0.3078. So I'm gonna calculate it, minus 0.378. So it's gonna be 0.1922. Okay, so this is the answer. Now I'm gonna calculate correct the answer. I will give 1 point here. If you show me you understand that, I'm gonna give you 1 point for the formula and 1 point for the answer. Okay, also 1 point for the area. Okay, also I'm gonna give 1 point here, 1 point here, and 1 point here. Okay, this is how correct the answer. Now let's see B. If a sample of 9 full-size rental car is selected, so my sample here is 9. Okay, what is the probability that the sample mean is more than 70? So I'm gonna see the mean for the population is still 64, and it's gonna be 70. Is more than 70, so my aim is to find this area. Okay, now my goal is to find the probability of x bar greater than 70. Okay, x bar because I'm using a sample here. Okay, now I know the mu is equal to x bar mu, which is 64. Okay, so I'm gonna use the z formula from chapter 8, which is x bar minus the mu divided by the standard deviation divided by n. By the way, you can calculate this separately and then edit it here, it's up to you. So it's going to be x bar, which is 70, minus the mu 64 divided by the standard deviation is 4.6 divided by square of n. Square of n here is 9 because it's a sample, so it's 9. So if you calculate it, it's going to be 3.91. So now I don't have here more than 3. Okay, now this is a tricky question because I don't have more than 3 in Z. How I'm gonna find that? Okay, I have another method to do that is so the other method to do that is, since I don't have this value here, okay, so how I can solve this problem? I'm gonna say probability of Z greater than 3.91, okay, equal to 1 minus the probability that of Z less than 3.91. Okay, now 1 minus, what is the probability that of Z greater than 3.91? Now it's 1. Okay, is 1. Why is 1? Because the total area here 0.5 0.5 is equal to 1. Okay, so you won't have any value for Z greater than 1. Okay, so I'm gonna assume it's 1, so it's gonna be 0. So the probability that is gonna be 0. Okay, always if you get a value here is not from the table, so assume this method. Okay, which is 1 minus change the sign here. Okay, this is by default. Change the sign here and then answer it like this. Hopefully you won't see this in the final exam, but just in case if you see questions like this, always do it by this method. Okay, CB. Now it has been reported that on average families in Europe eat frozen food 2.2 times per week, with the standard deviation 1.2 times per week. Assume that distribution of number of times that families eat frozen food is normal distribution. If a sample of 9 families is selected, what is the probability that the sample mean of the number of times families eat frozen food is between 2 and 3 times a week? Okay, now this is an example, I think, from chapter 8 also. So I'm gonna check if the result I will get is between this value. If not, we're gonna see. Okay, now first the problem asks you to find the probability of x bar between between 2 and 3. Okay, let's draw the problem. Now the mean here is 2.2. Okay, now it's between 2 and 3. 2 is here and 3 is here. So the question asked me to find the area here. Okay, so Z1 equal, let's assume this one is Z1 and this one is Z2, for example. Okay, so Z1 is 3 minus 2.2 divided by the standard deviation, which is, so here you have to write the Z formula from chapter 8, which is, let me write it here, x bar minus mu divided by standard deviation square n. Okay, so x here is going to be 3 minus the mu 2.2 divided by the standard deviation, which is 1.2 from the question, divided by n, which is n here is 9. Okay, 9 families. So do solve this problem. So it's going to be 2. Okay, so the area when z equal to 2, let's go and check that. Yes, it is going to be 0.4772. Z2 is equal to x minus mu divided by standard deviation square n. So x here is going to be 2 minus 2.2 divided by 1.2 divided by 9. So it's going to be 0.5 minus, okay, and the area, it's going to be, if you go to the z table, the area is going to be 0.1915. So now the probability that z is greater than minus 5, minus 0.5 less than z and z greater than 2, it's going to be 0.1915 plus 0.4772, and the sum is going to be 0.6687. Okay, if you do it like this, I'm gonna put 1 point here, 1 point for the formula, okay, and then half a point for your answer here, half point for your answer here. I'm gonna give 2 points here and 2 points here. Okay, this is the way how I can correct this answer. Question 5, this is the last question. So a quality control engineer is interested in estimating the proportion of defective items coming off a production line. In a sample of 200 items, 28 are defective. So required, find the 95 confidence interval for the proportions of defective from this production line. Okay, B, a laboratory tested 15. This is another question, so let's stick with A. So A, it asks you about the proportions. Okay, this is from chapter 9. So in order to solve the proportion, first, proportion is equal to x divided by n. Okay, x is the sample, which is 28, divided by n, which is the size of the sample. So it's going to be 0.14. Okay, now you have a formula here for the proportion, which is this is chapter 9. So here the formula. Okay, you have to use the confidence interval for proportions. B plus or minus z times the square root for b times 1 minus b divided by n. So you have to use this formula. So let's use it. So b plus or minus z times b1 minus b divided by n. That's the formula. Yes. Okay. So I'm gonna substitute the value. Now, do we have z here? We don't have z. So I'm gonna solve to find z. Z is, first I have 95% converted to decimal. So it's gonna be 0.95 divided by 2. So it's gonna be 0.95 divided by 2. It's gonna be 0.475. This is how to find z. And then z is equal, here find z. Okay, now I'm gonna find this area from the table. So this is the table. Where is the area of 0.7475? Okay, I'm gonna look to the table, find this area. So it's gonna be here. Okay, which is 0.750. This is the area. So my z here, okay, my z here is going to be 1.95. Because if you go to the, look to here, to the, it's 1.5, and top is, so added them, 1.9 plus 0.05, it's going to be 1.95. So this is the z. Okay, so I'm going to write it here. So z is going to be 1.95. So I'm going to substitute the value. B is equal to 0.14 plus or minus z, which is 1.95, square root of b, which is 0.14, times 1 minus 0.14, divided by n, which is, n here is 200. Okay, so now I'm gonna calculate that. First, so it's gonna be 0.14 plus or minus. So I'm going to calculate this portion first. So if we calculate this portion, it's going to be 0.05. Okay, so first I'm going to make a sum, 0.114 plus 0.05. So it's going to be 0.19, and 0.14 minus 0.05, it's going to be 0.09. Okay, so the confidence interval, okay, it's going to be the confidence interval, it's going to be 0.09 and 0.19. Okay, I'm going to correct this answer. I'm going to give 2 points for the b value. Also, I'm going to give 2 points, 1 point for the formula, and 2 point for all your calculation here. So here is 2 point and here is 1 point. Okay, and then I'm gonna give here 1 point and here 2 point. Okay, now let's see here. A laboratory tested 15 chicken eggs and found that the average amount of cholesterol sample mean was 187 milligrams with a sample standard deviation of 18.2 milligrams. Construct a 90% confidence interval for the population mean of the cholesterol content of all such eggs. Round your answer to 2 decimal places. Now, let's see here how we can solve this. This is also from chapter 9. So now I have 90%, okay, confident interval. Okay, now I have to find first freedom of degree, okay, which is n minus 1. Now, in here from the question is 14, sorry, is 15 chicken. So it's going to be 15 minus 1 is going to be 14. Okay, so I have 90% and I have the degree of freedom, which is 14. So I'm going to go to the t table and find the t value. Okay, so here, t table, I have 90%. Okay, degree of freedom, which is 14 here. So the answer is the t value is 1 point. Sorry, it's here. So it's going to be 1.761. Okay, so t. Sorry here. So now t is equal 1.761. Okay, now I'm gonna write the confidence interval formula, which is x bar minus t multiplying by s divided by n. Okay, plus or minus here. Now, do you have the x bar? Yes, from the question, which is the sample mean. The sample mean here is 187 plus or minus the t that we found 1.761 times the sample here, which is the standard deviation of the sample, which is 18.2 divided by square of n, which is 15. N is the size of the sample. Then if you calculate that, plus or minus, I'm going to calculate this part first. So it's going to be 1 point. So when we calculate this part, it's going to be 8.28. So now I'm going to first add it. So it's going to be 195.28 and then subtract. So it's going to be 178.72. So the confidence interval is going to be going to be 178.72, 195.28. Okay, how I'm going to correct this answer? First, I'm going to give you 2 points for the formula. Okay, also for t value, 1 point. I'm going to give you 2 points for substitute the value here. Okay, and then I'm gonna give you 1 point here and 1 point here. Okay, this is the way how I can correct the answer. Now see, interpret the result. The intervals you got in both scenarios given above A and B. Now A is here for A is 95% confidence interval that the population proportions of defective from this production line is between 9% and 19%. Okay, which is mean between this interval. You have to convert it to percentage, so it's going to be 90% and here 19%. Okay, B the same, 90 confidence that the population mean of cholesterol contact all such eggs is between 178.72 milligram and 195.28 milligram for the sample size of 15. Okay, how I'm gonna write that? You will write like this. Okay, 95% confident that the population proportion of defective from this production line is between, remember here is percentage, so you have to convert it from decimal, so it's going to be 9% and 19%. Okay, for B, 90% confidence that the population mean of cholesterol content of all such eggs is between 178.72 milligram and 195.92 milligram. Okay, this is how you can write this. Hopefully, because you only have 1 hour, they will want to give you this scenario, but in case you have to do it like I did now. So this is the end of all of the final. Okay, try to solve by yourself, go through each question, and if you have any questions, just let me know. And good luck.